Hello grade 12s, welcome to my channel and let us have a look at this paper review. It was a request by one of you guys. This can be used as a form of preparation, revision for the next paper 2 on Monday. So those of you who have been learning through my channel should probably, what can I say, they should have cruised paper 1 yesterday, isn't it? Because if you watched my content properly, not necessarily passively but actively watching it and putting it to practice, you should have scored a distinction in that paper. But for those who are careless, and especially those who just follow the wind, who don't learn much, unfortunately that paper must have percussed you badly. You probably have given up on maths by now, but hey, don't lose hope. But what you need to do is to make sure you don't just follow the wind like the paper. Be like a tree that is rooted. You just move a bit to show where the wind is going, but you don't change your position that much unless we transplant you. Anyway, guys, let me not say too much before I start sounding a little less mysterious. We're doing maths paper 2 from 2019 May-June exams. I got a copy here from essay exam papers, and what I like about it is the study. If you don't, anyway, instructions, guys, of a serious necessity. I would not say they are the only ones. Of serious necessity are these ones. And what I like about that very first one, not first one, but the third one, is how we score marks mostly. And people forget this one and it catches them out always. And here we are to round off correct to 2 decimal places only, no more than 2 and no less than 2 decimal places. And of course we need to understand the rest of the other instructions to ensure that we score full marks. Okay, let's get to the paper. So question 1 reads, each child in a group of 4-year-old children. So what is this group? It's a group of 4-year-olds. Was given to the same, each child in a group of 4-year-old children was given the same puzzle. Okay, that's a controlled variable. To complete. The time taken in minutes. See? Time taken and in minutes. By each child to complete the puzzle is shown in the table below. Of course, these ones are the higher grade students, the quick ones, the effective ones. In just 2 minutes, in less than 6 minutes, greater than 2 minutes, these guys were done. These ones are most of the bulk of the students, perhaps. These ones too are not too bad, but these ones, yeah, they are struggling, especially the last 2. So again, be in the habit of understanding the significance of the summary of data that you're given. Now the question says, how many children completed the puzzle? Of course, here our task is to find the sum total of these children. Because the frequency there will give us the total, which we can place down here. All right, so this is 2 plus 10 plus 9 plus 7 plus 8 plus 7 plus 2. It gives us 45. So there's 45 children here. So let's start. Okay, my table, guys, makes a lot of noise, so hope you will forgive me for that. So we can say 45 children. Please answer in full. Great. 1.2. We need to calculate the estimated mean. Okay. Time taken to complete the puzzle. So now for this, we need a few things. We need to find the midpoints, call it x. So 6 plus 2, that's 8 divided by 2, it gives us 4. Then the 16 divided by 2, that's 8. That's 24 divided by 2, that's 12. So you can see it's going up in 4. So the next one is going to be 16, 24, 28. Wait. Mistakes. 4, 8, 12, 16, 20, 24, 28. Okay? Of course, you can check. This is going to be 56 divided by 2. It's 28. So this is good. But of course, if you're not confident, try to do something else. Now, the other thing that we need here is to essentially, find the cumulative frequency, not cumulative, but the midpoint multiplied by the frequency. So this is 4 by 2, we get 8. Then we get 80. Then 12 by 9, is it 160? 12 by 9 is 108. Yo. Meta yaziwa up. 16 times 7 is 112. And then 20 times 8, 160. Then we have 24 times 7, it's 168. Then 28 by 2 is 56. Alright. So of course, guys, we need the sum total of these as well. So we can start from 56 plus 168 plus 160 plus 112 plus 108 plus 80 plus 8 gives us 692. Of course, the person who knows how to use the table can easily do this on the calculator, but sometimes a bit of the mechanical work needs to be understood, right? So to find the estimated mean here, we can say x bar is going to be the sum of the frequencies multiplied by the midpoints divided by the number of them. So this implies that x bar is 692 divided by 45. Therefore, the mean is 692 divided by 45. So we're getting 15,38 to 2 decimal places. But remember, this is minutes because this was mean time. So make it a point, guys, that you answer the right way or you don't answer at all. Okay, be very careful. Here, usually the answer only, provided you will be unit specific to the question. Remember, we are answering the question. This other stuff is not really that big of a deal, but someone may find a way of distributing the marks. Perhaps this step of substitution and the answer could be considered if we want to split these marks or distribute them. All right, 1.3. What do we get? We need to complete the cumulative frequency column. So in fact, I'll just say cumulative frequency here. So this is just going to be 2. Then we add 10, we get 12. We add 9, we get 21. We add 7, we get 28. We add 8, we get 36. There we get 43. then we get 45. And usually the last cumulative frequency should match the total of our data points, and that is the children, the 4-year-old children. So we know that that is done, so we can just simply say see the duffel. See the duffel. All right, great. So we get our 2 marks there as well for completing our table. I don't have it here. So 1.4. We need to draw the cumulative frequency graph, or the ogive, to represent the data on the grid provided. Of course, I don't have that grid. So what I'm going to do, I'll just set up my template so that it can do the graph. All right, so once that is done, what can we do next? Well, we just draw. So I'm going to try to do it quickly, guys, because this is time consuming. You just have to find time to do it well. In fact, practice it enough to do it fast. Okay, guys, so there's my cumulative frequency graph. As you can see, I chose a scale that is going to work. This is 0, by the way. And then we can see we have to anchor this on the lower limit of the first class, and we always draw our cumulative frequency graph based on the upper limits of each class. And this is what we get. Of course, one can actually stretch the x-axis and make it wider, and it may look a bit nicer, but as long as it is S-shaped. Sometimes it may have bumps depending on how well the data that we have works together. All right, so this is the cumulative frequency graph that we needed. So we get our 3 marks. And how do we get this? The shape, S-shape, we need to appreciate it. That's the first mark. Anchoring, that's another mark. Third mark is literally all the labelings, the correct, topic there. We need to show that this is the ogive of the data, and the time in minutes, the cumulative frequency, and everything, seeing those points. So that would be the extra mark, I suppose. Okay. Last question here. This is 1.5. Says we need to use the graph to determine the median time taken to complete the puzzle. So of course, to do the median time, we just take 45 and divide it by 2. It's going to give us 22.5. That should be between these two. So it goes like this. And we take it down to the we take it down to the ogive. It's exactly at 15 minutes, but again, it will depend on how accurate your graph is. So what I often do, I break this up. So we take it to the ogive, and then we take it down to the graph. So this is approximately 15 minutes. All right, so again, the method on the graph, 1 mark, and the answer perhaps, but even answer only, you get 2 marks. But for the fact that someone said use the graph, I would suppose the method here would be the extra mark perhaps. So the 2 marks come from that. All right, okay, all right. Perhaps we may need to indicate that this is 22.5 over there, just to make sure we don't lose marks here. So what is this? So this must have been a very simple 10 marks. But the labor intensive part, folks, is actually question 1.4, because drawing the ogive is a bit tedious, a process. But once you get used to it, you are good. So let's move on to the next question. So we will have question 2. So in question 2, what do we have? Now question 2 says learners who scored a mark below 50%. Okay, so a mark as a percentage, right? We're not talking about a mark in terms of the actual mark scored, but we're talking about the percentage obtained. Okay, in a mathematics test, we're selected to use a computer-based program as part of the intervention strategy, maybe to try and improve those marks. On completing the program, these learners wrote a second test to determine the effectiveness. So the second test was all about the effectiveness of the intervention strategy. Now the mark as a percentage, again, can you see? Mark as a percentage, not the actual mark. Scored by 15 of these learners. Again, we start to know now how many they are. In both tests is given in the table below. Right, not a problem. So we will see that this is the first test. Again, what is important to note is that this is percentages, not the actual marks. Please guys, make sure you are very specific in the piece of information given so that as you answer, you also answer specifically. Now let's see, literally the marks here have improved, right? They have improved, but this one, this one did not really improve, eh? This one did not improve, instead dropped by 4 points. So what could be the reason? Perhaps the student came late when the program was being explained on how it works, and so couldn't use it properly within reasonable time, perhaps lost time. That's possible. Or the learner just doesn't like technology, is not technology oriented like myself. There are many reasons, of course, that can explain this. Maybe the computer jammed and gave him hell. Yeah, whatever. But in general, we can see everybody seemed to improve from the marks they got. Okay, not a problem. So here, this just shows the program is effective because it correlates with an improvement for the majority of the students. So 2.1 says we need to determine the equation of the least squares regression line. Okay, now this is a bit of a tedious thing. We need the calculator for this, so I'm going to do it quickly on my calculator. Of course, what do we do here? We go to mode, we go to stat, then we choose the a plus bx, which is option 2 on my Casio. Then we input these x values and input these y values, and then hit the AC button to store that data, and then we start regressing. All right. Okay guys, I've input all the data into my calculator. Now we regress. We go shift, press button number 1, and then we press option 5 there, which is regression, whatever that option is, and then we choose option 1 for A. So A here for me is equal to 12,44 to 2 decimal places. Let's look for B. We just continue shift, button 1, regression, then we choose B. So this is 0,98 to 2 decimal places. Therefore Y accent is going to be 12,44 plus 0,98x. And that's the answer. Please guys, be very particular about the notation. This is not just any ordinary Y. It has an accent on top. If you're not sure, go straight to, what you call this thing, the information sheet, just so you can get an idea of the right thing. How is it given here? It's given the right way, okay? So again, these ones can be substituted for A. capital letter A and capital letter B. All right, so that is good. That is excellent. That is brilliant. So let's move back. Sorry for the back and forth, but I just need this to be clear, guys, so that we don't do bad things here. So we get 1 mark for each and the final finish. Very easy question, quite common. 2.2 with 2.2.1. We're told a learner's mark in the first test was 15 out of a maximum of 150. So this is now the actual marks. The 15 is not the percentage, it's an actual mark. Now we're told to write down the learner's mark for this test as a percentage. Now as a percentage, we just say, perhaps we might want to go back. There's nothing on the correlation coefficients, but sometimes you want to skim and scan to see if you still need the stats mode here. But I can go back to the normal computing mode. So this is 15 divided by 150, which we then multiply by 100%. It is literally just 10%. Okay, so very easy. 1 mark. Now, if you didn't know how I did it, I just took the 15 divided by 150, and then we multiply this by 100%. All right, not a big deal. So 2.2.2 says we need to predict the learner's mark. Now remember, when we talk marks, we're talking about percentage for the second, because if we are to predict, then we see whether this is an interpolation or extrapolation. Okay, predict the learner's mark for the second test. Give your answer to the nearest integer. So what are you going to say? What must you say, folks? Remember, this is 10%. Do you see that there's a 10% here? What did we get? 33. But remember, we're not correlating what was actually on the table. But now we just want to predict using our least squares, because once we say predict, we want to use our least squares regression line. So we're going to say y accent is going to give us 12.44 plus 0.98 into 10. This implies that our y is equal to, let's see, this is 12.44 plus 0.98 into 10. It gives us 22.24. So, which is approximately 22%. All right, so this is good because we were told to round off to the nearest integer as well. So there was a further instruction here. So the substitution and the answer, don't forget, this is a percentage. It's not just a mark, okay? So simple things tend to haunt people who are not paying attention. Okay, let's get to 2.3. We are told that for the 15 learners above, the mean mark of the second test was 45.67 and the standard deviation is 13.88%. The teacher discovered that he forgot to add the marks of the last question to the total mark of each of these learners, okay? Now all the learners scored full marks in the last question. So when the marks of the last question are added, the mean mark is Okay, now there's a new mean mark once all the marks have been added. So it increased, of course, because we added an equal measure for each learner. Now the question says, what is the standard deviation after the marks of the last question are added? So, well, the standard deviation, since we added the same measure to each point, so the distance between these data points from the mean is going to remain the same. So it's going to be 13.88%. So this is just to say, do you know how this affects the standard deviation? Again, it goes to saying, does the student know what the standard deviation is? It's basically the average distance of each data point from the mean. So if we increased each position by the same measure, that means the mean will also increase or change the same way. That means the standard deviation remains the same. The next one, it says, what is the total mark for the last question? Of course, it is just going to be the increment of the mean from the first one to the second one. So we can say the mark is equal to, of course, we're talking in percentage here. So this is going to be the difference of the two means. So this is going to be 50.67 minus 45.67, which is going to be equal to, 6 sevens go out, 50 minus 45 is just 5%. Nice and easy. Okay, so again, knowing that it's going to be the difference of the standard deviation, of the means, and giving the mark with the right unit is the most important. I know students take this for granted and they go down by the head for these very lousy mistakes. So it helps to be very, very compulsive and obsessive when it comes to maths, or else you will be in trouble. So the terminology is important in maths. The notation, correct notation, is important, and being specific to your curriculum is also important. Then you can be flexible on areas that are certainly open-ended, but be very, very, very careful on how that is executed, because certain things need to be clearly explained before they can be applied. All right, folks, there's nothing much to say here. Easy 10 marks otherwise. So we move on to the next question now. This is the start of the big things. So we're going to have question 3. Usually it's a question from grade 11, but it may have spices of grade 12. All right, so what do we say? In the diagram, A, B, C with coordinates 2 and minus 3, and D with coordinates minus 2 and minus 5 are vertices of a trapezium. So what is a trapezium? A trapezium is a geometric, in fact, it's a quadrilateral that has a single pair of opposite parallel sides. So we're told AB is parallel to DC and it's indicated. So nice and easy. Now, the fact that these coordinates A and B are mentioned but not given, it already says this is a potential question. So we need to figure out how we're going to get those coordinates. Right, so we're also told that E with 2 and 0 is the x-intercept. Of course, any point that has a y value of 0 on the Cartesian plane, it's an x-intercept of a line made by points it is collinear with. All right, so this is the x-intercept of AB, so not a problem. So we can see that point E right there. And we're told also that the inclination Really? Inclination or angle of inclination of AB is alpha, but again it's indicated, so supposedly it was meant to be the angle of inclination. K lies on the y-axis, and of course, why does K lie on the y-axis? It's just to try and show us that it's a point collinear to any point on the y-axis, or is any point on the y-axis, but I suppose K is for the purpose of defining theta in terms of KBA or ABK, right? And there it is now, KBE. Can you see KBE is theta? So it was for that purpose. All right, so once we read the statement and understand, what can we do with it? Well, we'll see that we've got 2 points on DC. This means we can work out the gradient and the equation of this line. From the equation, we can read out the y-intercept. Okay, that's about it here. But now we can transfer the gradient of this line to that of AB, because parallel lines have equal gradients. And seeing that we've got a point here, we can work out the equation of this line. From the equation of this line, we can read off the y-intercept B. And from the gradient, which we can get from DC, we can actually work out the angle of inclination of alpha. Nice. Now, once we get the coordinates of B, which we know x is 0 because this is on the y-intercept. So this is 0 and some y value, which we need to find out. And then we will have, yet again, a set of points on BC. We can actually work out the equation of this line and its gradient. And from the equation, we can work out the x-intercept and its angle of inclination. So that's about what we can do. But now, this one is a bit elusive, so we may say probably we need extra information to get AD or the coordinates of A if they be needed at some point. Of course, once there's some question like this, it helps to skim and scan these questions to determine how this extra information can be used beforehand, guys. Because if you start seeing this piece of information when under stress already, you will crumble. I tell you. So we want the midpoint of EC. Okay, EC becomes this line. Hayibo. Hebana. Iyangihlolela. Ingiqhela kabi yazi. Ingiqhela la way. All right, so this is just the suggestion that we want the midpoint. But of course, carelessly looking at it, I would suggest that perhaps this is the midpoint right there. Of course, this is just a careless look, guys. Don't read too much into it. Will it fall there? We will see. But if you look, for sure it does, because if we say this plus that, guess what? It's going to be 2 minus 2, which is 0. 0 divided by 2 is 0. So the x-coordinate is 0. It definitely does fall there. So be in a position, guys, to think about how you're going to do things. And then, of course, the gradient of DC, we've got 2 points. Equation of AB, we're going to use the gradient of DC and that point E. Size of theta. Okay, how are we going to do the size of theta? Of course, the gradient of this line gives us alpha. And at the origin, we have 90 degrees. Right? So this means this triangle right there, we will know this is 90. We will find alpha. That's the exterior angle of that triangle. So we'll be able to find theta. We need to prove that AB is parallel to BC. Of course, it means we need to find the coordinates of B first, then find the gradient of BC and multiply to the gradient of AB, which is as good as that of DC. Then if we find the product to be minus 1, then this is going to be 90 degrees right here. So we can as well suggest that this is so, because that's exactly what it is. All right. So we're told also points A, B, and C lie on the circumference of the circle. So if these lie on the circumference of the circle, so it means there's a circle around here. So let's try to make it look like so. Oops. All right, so we'll adjust it nicely, don't worry. So there's that one. Then there's this one. Okay. Okay, all right, okay. Hey, stop jumping around when man. Gonna drive me crazy. See now this thing. It has not done what I want. Calm down, boy. Boy. So of course, guys, it's not exactly nice and perfect, but we get the suggestion that the examiners are trying to transmit to us. So if it was not given, so this is the circle that we see, okay? Means there's a circle around those points. So what does it make these points now? When there's a circle around them, it makes them concyclic. That's the terminology. Concyclic points. Now, concyclic points fall on the same circumference. Great. Now, if this is 90 degrees, then this must be the center of this circle, right? Because we know that angle in the semicircle is 90 degrees. Now, we have that as 90 degrees. We've got the midpoint right here. This line, this becomes the diameter, so this essentially becomes the center. Great. All right, okay. So we then have to find the center of the circle, and guess what? The center of the circle is nothing but the midpoint of EC. Converse of the angle in the semicircle. Lovely stuff. And then we've got the equation of the circle in the form, okay, that's fine. We will have the center, then we have any point on the circumference. We will be dealing with that nicely. And again, this one is related to which question? This question, in terms of finding the coordinates of B, literally. So the examiners are very friendly. They always provide a way of seeing, and we can see that as much as A needs extra information, there's nothing on it. So we don't have to concern ourselves with it, okay? So let's see, 3.1, what can we do? We know that the midpoint of EC, we can say let F be the midpoint of EC, such that F is going to be x at C plus x at E divided by 2 is to y at C plus y at E divided by 2. Remember, guys, formulae need to be written before we do any form of substitution, except when we have done this above, then we may not need to write the formula again. So x at C is 2 minus 2 divided by 2 is 2. Y at C is minus 3 minus 0 divided by 2. So therefore, the midpoint F is going to be 0 is to minus 3 over 2. And we can clearly appreciate that that point F right there is giving us the vibes. is giving us the vibes. So we know that point F came out as 0 and minus 3 over 2. Nice and easy. So it is done. Now how do we score marks here? Of course, substitutions into the formula and the answer, because here this is all about the method. The method. 3 point, oops, now you see I'm not doing the right things. 3.1.1. This becomes 3.1.2. We need to find the gradient of DC, so M sub DC is going to be y at C minus y at D divided by x at C minus x at D. This is equal to y at C is minus 3 minus y at D is minus into minus 5 divided by what is this thing now? X at C is 2 minus into minus 2. All right. So this is minus 3 plus 5, which is 2. This is 4, so 2 over 4 is a half. Okay. Nice and easy. Not a big deal. Again, we never calculated the gradient in this question, so the formula must come out. But let it be specific to the question. The generic one is just for you to gain some template. It's a template, guys. It's not a necessity for you to copy it that way. Don't listen to those who tell you to do so. It's a mere suggestion. Please be specific, because if you don't become specific, it means you don't understand what you're doing. And for us, they're very strict markers. Okay, if I would consider myself a marker, I would say the student copied, because if you show me that you don't really understand, then it's easy for me to assume you've copied. And I'll start judging you based on each and every question. And therefore, once I find a discrepancy, then I will flag your paper as the one that has a possibility of some chicanery. And you know what? Your marks will be withheld and you will not be able to use them, within reasonable time. So please, guys, don't victimize yourselves over carelessness. I know most of your teachers are very careless themselves, but purely because they don't really fully understand the subject, or at least their confidence is not so great. Now they transmit that weakness into you. So be very careful. But at the same time, be very, very friendly and try to not sound too smart to your teachers. Okay? Do what they want, but knowing beyond what they want from you, because they will victimize you in the exams. And your teacher is not necessarily going to sit for the exams. So be very careful, guys, who you listen to and what exactly do you take from them. Anyway, let's move on. This is suggesting we need to find the equation of AB. So we know that AB as a line is such that y is equal to half x plus c. Why do we know this? We know that the gradient of AB is going to be equal to the gradient of DC. Right. Since they are parallel, given AB parallel DC. So guys, it helps sometimes to justify your actions. Otherwise, you end up in trouble. So now point E is collinear on this line. We can substitute the 0 into minus 2 plus C. Therefore, our C comes out as, this is minus 1 transposed, becomes 1. Therefore, the equation here is y is equal to half of x plus 1. And guess what this does? The y-intercept here is point B, so it means y here is 1. So we've got 4 coordinates of point B. So can you see certain questions uncover certain issues that we already mapped out? I would suppose that is mark worthy, substituting a point nicely there, and literally writing our answer as required should be the 3 marks. So let's see, 3.1.4, we now need to find the size of theta. Nice and easy. So we saw that in triangle BOE, or buoy, depends on how you want to pronounce this thing. So what do we know, folks? Theta is basically KBE. It's going to be equal to BO plus EOB. Perhaps let's just write it as B, B or buoy. Now, what do we know about this? This is the exterior angle of a triangle, which is the one we're talking about. So this implies that theta, because that is theta, is going to be equal to alpha plus 90 degrees. Why do we know this is 90 degrees? Because that's the origin. So the x-axis meet the y-axis at 90 degrees. Okay, so this further implies that theta is equal to, this is the shift 10 of the gradient of this line AB, which is a half, plus 90 degrees. This still implies that our theta is, now shift 10 of a half, what do we get? Shift 10 of 0,5 is 26, comma, now we can make this one to 2 decimal places, 57 plus 90 degrees. Therefore, our theta is going to be this business here. It's 116,57 degrees. It is done. So can you see, guys, skimming and scanning some questions. Remember, in the exam, it's all about maximizing. It's not about now the procedure. While practicing, it's okay to just surprise yourself, but in the exam, you want to make sure you answer what you can when you really want to answer those that you can. Because at times, the time factor here is more important. Of course, the rule here, very important and justified by the reason. Great stuff. Perhaps here I would say this calculation was key in the final answer. Okay, so that's how the 3 marks comes about. This angle is perhaps one you should know. If you don't know, you are dead. Akunjalo. So 3.2. We need to prove that AB is perpendicular to BC. Okay, we know the method here. We can say gradient of AB times the gradient of BC. Okay, first, before we start here, we need to state that B is 0 and 1. And we need to say something here. It is the y-intercept of AB. We know that x is 0 at the y-intercept and 1 the constant of the equation. So we can simply say then we know that the gradient of AB multiplied by the gradient of BC should give us that of AB is a half into, since we have used the formula for the gradient above, we don't need to say it again here. So what needs to happen here is just simple substitution. So we can say minus 3 minus 1 divided by, this one is going to be 2 minus 0. So this is equal to a half into, this is minus 4 divided by 2, it's going to be minus 2. So this is indeed minus 1. And if this is the case, we can make a conclusion therefore that AB is certainly parallel to BC. The reason is because the gradient of AB multiplied by the gradient of BC gives us a minus 1. Remember, a proof, guys, treat it like a Euclidean geometric question. There has to be a reason, unless, of course, it's not necessary. Perhaps here it's not really necessary, but be in the habit of being clear. Showcasing that you know what you're doing is really important, beyond just, going through the motions. Now, stating this properly. Yes, you may find that a memo may just state this without a reason, and then you get the impression that you don't need a reason. But you, as a student, you must provide a reason. If you did not show the calculation, there has to be something that justifies you saying that, because you may have copied it from your friend. Your teacher may have whispered in your ear, so you did not understand why it's so. This is why it just, hangs in the air. But remember, answers don't hang in the air. They come from something. So please show us that something that emanates these answers. We don't want answers that are flying and we don't know where they come from. Sorry. So guys, I'm warning you. You will lose marks unnecessarily because of carelessness. Of course, the gradient here is the most important. And I would suppose the answer here is also key. And technically, it justifies the conclusion somewhat. Sometimes you are told the final answer does not necessarily get a mark because it's already suggested and perhaps we're just giving a reason. All right, let me charge my tablet. My Daffeliki. Let's judge the Daffeliki. All right, okay, all right, folks. That was 3.2.1. I like to not do things properly lately. I think it's the talking too much, Is that the feel brat so. So this is 3.2. 3.2.1. Lord have mercy on this dude. You see what I'm doing now? I'm creating chaos for myself. What am I doing now? I am committing suicide now. This is good. Ish, you see? You mess up something good and you make it bad. Okay, let's get to 3.3. Now we need to deal with this situation, and we could see our nice circle there coming up. We need the center of the circle, 1 mark. Okay, we know that the center of the circle is going to be F, which is 0 and minus 3 over 2. Perhaps we may want to justify this because remember, guys, the question said determine. Sometimes by inspection, okay, it's good, but I'm wondering, are you just guessing or are you giving it or did you copy? Remember, guys, we need to guard against giving the impression that we copied. It's an offense that is punishable. Okay? So try to portray that this is you doing your work through your understanding of the subject, following the correct and acceptable rules or techniques or means of solving while paying attention to instructions. Okay. So what do we know here? Well, we can say EC, EC is the diameter of circle Right. How do we know this now? This is the converse of angle in semicircle. Since, what was that angle there? Since EBC is 90 degrees. You see, guys, find a way of, suggesting something. Yes, it's not necessary, but one day you will thank me for this, because remember, you're still going to do some higher order math at university, at college, when you are dealing with issues higher than metric level, which is N3 at our colleges. You will start to see yourself needing to write proofs, math proofs. They will horrify you if you cannot align things properly. But again, it depends on your enthusiasm for the subject. If you're a lazy bugger who just wants to get through things, you will get through this one and fall the next attempt you make. And then you'll be wondering what happened. You will think they bewitched you, when you in fact bewitched yourself by being careless. Now we need to find the equation of the circle in this form, which is great. So we can say circle F, since we now know this is the center, is such that x at F is 0, all squared into y minus is going to be plus 3 over 2, all squared should give us r squared. All right, now through this point C, where we have 2 and minus 3, it will be such that 2 minus 0 all squared plus essentially minus 3 plus 3 over 2 all squared gives us r squared. Therefore, our r squared comes up nicely. So we've got 2 squared plus into minus 3 plus 3 divided by 2. That is squared. It gives us a 25 over 4. So therefore, our circle here is x minus 0 plus y plus 3 over 2 all squared equals 25 over 4. Okay, it's nice, it's easy, it's beautiful, is elegant. Anyway, anyhow, folks, writing it this way, perhaps focusing on substituting the center and then substituting the point, which is concyclic, and getting the value of r is key, and then finally writing it nicely all together. Another student may just want to simplify the first bracket, because if we're taking nothing from the variable, we may as well not even care. So this is also correct to give. Okay, one may want to give it that way, it's still fine. All right, guys, so that's a very easy question. Otherwise, you can see this is purely grade 11 with perhaps the spice of grade 12 for 3.3. This is the grade 12 part. As I said, you will often get a mixture of the two. Grade 11 mainly, and then a portion of grade 12 for question 3. That's how it's asked. So guys, please pay attention to things. Pay attention to things, how they move, or else you will wonder what happened. Okay, let's move on to the next question. question 4. So we are told here in the diagram, the circle is centered at M. So there's a circle here centered at M. So there is M. Let's use another color with the coordinates 2 and 1. Radius KM, okay. Produced to L, okay. If it is produced, it means it's the same straight line. A point outside the circle. So meaning ML is not equal to KM. So this statement here is just suggesting that KM is not equal to ML. Do not make the mistake of saying that. Okay. Now, such that this KML is parallel to the y-axis, and that is indicated. But now what do we know? This is the origin, which is not indicated, which I hate, because it should always be if this is a Cartesian plane. But perhaps the examiner is trying to find out if you know where the origin is. Where the x and the y-axis meet, it's the origin, and so they meet at a right angle. So if these two lines are parallel and that angle is 90 degrees, this one should also be 90 degrees, right? Yes, why? These are corresponding angles when those are parallel lines. So we understand what this means. Again, interpret each piece of information so that there's no issues. So what does this mean, folks? It already means the x-coordinate at M is the same as the x-coordinate at L. As well, it is the same as the x-coordinate at K. So the only difference are the y values, because if this becomes a vertical line, the x value at any point on this line is going to be the same as the one that is identified, at least. All right. So these are pieces of information that are just trying to drive us into some winning formulae. Anyway, LTP is a tangent. See? Now this is a more of a grade 12 question, right? Because question 4 has a circle involved, which is what you study in grade 12. All right, at this point, again, there's a B there, which is suggesting that this is a question somewhere in the questions. If not, we will need it to work out something else. All right, so we've got S as the midpoint of PK. So we've got the coordinates. It means we just need the coordinates here of K. Because once we find the y value there at K, we will then use the midpoint to get to P. Because it means P is also another potential question. Usually with the grade 12 question, you're not given everything in full. So everything works sequentially from the questions in a scaffolded pattern. All right, so what can we do now? Well, we can see that if we find this K, we will be able to find P. And literally, if we find this B, we use this gradient to find the gradient of this line and its equation. We can rid of its y-intercept. And knowing the x value now, because that point L is collinear with T and P, then we can find out that y value. So it's going to be quite a complex work here. And of course, once we know how to find this y, which we don't know at this moment, we will then be able to work out those coordinates. So it's going to be a bit of a challenging situation. But once we have an understanding, we continue to move. 4.1. By the way, we were told something that LTP is a tangent to the circle at T. And if this is the center, it means we have a circle here. Let's try to approximate it. Okay, so we need to make this circle look like it. Okay, it looks like it, right? Right, of course it's not 100%, but is looking like the 1, is looking like the 1. And if this is the circle, therefore this become already nice and easy. So this is the part that makes life a lot easier. Of course, I'm using the technology. You don't have this luxury in the exam. But hey, have an idea. Sometimes a very rough sketch can give the impression. What else do we know? If this is the tangent, it means this must be 90 degrees as well. I went on some goodness. It's getting in a lento sometimes in Papin. Anyway, that's 90 degrees over there because the tangent always meets the radius at right angles. So that's the impression. So of course, guys, these are the pieces of information that we need to put together as we interpret the statements before we start choking on the questions, because we get a serious choke. Now, given that the radius of the circle is 5 units, can you see? Now, this is the radius, 5 units. If this is 5 units, that should also be 5 units, right? Right. Because they are ready. Now we need to show that B is 4. That's easy. Now we can use the distance formula between M and T. So we can just say, folks, we understand that MT squared should be equal to 5 squared, because MT is the radius. Now we continue and say this implies we're using the distance formula now. X at T minus X at M all squared is going to be equal to Y at T minus Y at M all squared should be equal to 5 squared. Now we substitute. Remember, if we did not show the formula at first, we must show it at least somewhere. So Y at T is B minus, what am I doing? X at T is minus 2 minus X at M is minus 2 plus Y at T is B minus Y at M, which is 1 all squared, is equal to 25. Okay, this implies that this is minus 4 squared, which is 16. This one let's leave as it is so that we can avoid, needing to factorize later on again. So we then transpose the 16. B minus 1 all squared is going to be 25 minus 16 is 9. Then the gymnastic is to take the square root. What we do on the one hand side has to happen on the other side as well. So this also implies that B minus 1 is plus or minus 3. Now we want the positive answer here because this is the point in the second quadrant. Y is positive. So we can say therefore B is going to be indeed plus 3 plus 1 is going to be 4. We only choose the positive answer because the other one would be directly opposite that, which would be at this point. And we can see that would be minus 3 plus 1, that would be minus 2. So we cannot choose that because that would be the point in the fourth quadrant. All right, so this is the story that we get, and we stop right here. So essentially, substitutions here, very important, I guess. The gymnastic, I suppose, we get a mark, and what is the story? I don't know, guys, but how many marks are we scoring here? 4. Wow, we can say general substitutions and then maybe substitutions into that distance formula. Third mark, maybe selecting the right answer, I suppose, makes sense. or even this statement is quite key, to be honest. But sometimes the mark allocation, don't worry too much about it. Worry about ensuring that you score maximum marks, that's all. So 4.2, which is 4.2.1, we need to determine. Now, a question that says determine is an open-ended question. We can do it by any means necessary. The coordinates of k, nice and easy. So what do you see? Well, we can see that k is essentially going to be 2 is 2. Now, once we know that this is 5 units, what do we know? It means we're moving point M down to the circumference. So the vertical shift here is going to be 1 minus 5. It gives us minus 4. At this point, we can just get marks for the answer. Nobody cares how we did it because a determination can be by inspection. But at times, you may want to showcase how we did this. It's not a big deal, but just for 2 marks, don't sweat. Answer only is acceptable. Now, the equation of this, except when the question said calculate, and that's a different story. Show, even if it's for 2 marks, you show everything you can. Now, the equation of the tangent, so we want the equation of the tangent LTP in the standard linear format. Not a big deal. So first of all, we know that the gradient of LTP multiplied by the gradient of MT, or let's just say TM to avoid this crazy look. So it should be minus 1 because the tangent is forever perpendicular to radius. Nice. So this implies that the gradient of LTP into, so we did not necessarily calculate in this question the gradient, so we may want to show everything into y at m minus y at t, all divided by x at m minus x at t is equal to minus 1. This implies that the gradient of LTP into y at m is 1 minus y at t. We got minus 4. 4 divided by this one is going to be x at m, which is 2, minus 2 is going to be plus 2. Must give us minus 1. Please be patient here. This is MLTP into, this becomes minus 3 over 4 minus 3 over 4 is equal to minus 1. Therefore, the gradient of LTP is going to be equal to, we flip this and we take the opposite sign, it's going to be 4 over 3. Okay. Now, folks, you may want to perhaps look for the gradient of Tm separately, but I'm just showing that sometimes you can just do things at once to avoid writing too many steps. So what do we say now? We can say then we understand that LTP, the line LTP, is such that y is equal to 4 over 3 x plus c. Now the collinear point to this is point T. Minus 2 is to 4, such that 4 is equal to 4 over 3 times minus 2 plus c. Therefore, c here becomes, now this is minus 8 over 3. When it goes over, it becomes plus 8 over 3. Now 4 by 3, that's 12, plus 8, it gives us 20 over 3. Okay, you need to know about fractions, but if you don't, it's not a big deal. This concludes that y is 4 over 3 x plus 20 over 3. Nice and easy. Let's see what is 20 over 3. 6,67, which is approximately 7. So this is 4. For this to be 7, it's not too far off, isn't it? Yeah, so it's not too bad. I can accept this equation as my proper answer to the question. Of course, nothing is drawn to scale, but the proportions must be proper, okay? They have to be proper, okay? Now, this statement is key because it helps us to do the things. Now, this gradient is key, and this gradient is key, and the substitution of the collinear point and the answer, because it's very important. This could have been 1, 2, 3, 4, 5 marks. Wow, and it's only 4 marks we are getting. 1, 2, 3, 4, 5. It means we need to drop this because it's too obvious, I guess. Yeah, I guess so. This was a calculation, mark worthy. This is a serious determination, sure. So these are 4 marks, no problems. This was 4.2.2, so now we're going for 4.2.3. We need to find the area of LPK. Okay. Now where is this LPK? So technically it is this big triangle. Okay, how are we going to deal with it? Fine, we have found the coordinates of k here. This is -4. We got it. Now, we literally need to find this y value over here. Because once we have the y value, this becomes our base. And we can extend this side a little bit. Okay, and we can draw, remember this is a scalene triangle of some kind. So this can become our perpendicular height. Right. So this can become our perpendicular height. I don't know what I'm doing right there. Okay, so this can become our perpendicular height. So what do we know? Well, it just simply says we need the difference between the x value at k and the x value at, so this is going to be the difference between these x values. So that's the horizontal distance. That gives us our perpendicular height. Otherwise, the base side here is going to be the difference between the y values here. So the difference between the y values is what gives us our base. So understanding what we need is good. Shabzinto. How do we find that? So we will say, well, we will say L is this point, 2 is to y, such that y is equal to 4 over 3 x plus 20 over 3. Okay, those points are collinear to that line, so we will then substitute. Say this implies that y is equal to 4 over 3 into 2 plus 20 over 3. So therefore, let's just simply imply y equals, so this is 8 over 3 plus 20 over 3, which is going to be 28 over 3. So you can say therefore L is the point, 2 is to 28 over 3. Very important, because we know this y value will help us to find our basal side. Okay, now we also need point P. You can say also P is such that x at P plus x at K over 2 should give us x at point S is 2, y at P plus y at K divided by 2 should give us the y at S. Alright, so this implies that P is going to be what we want, x at P minus x at K, plus 2 over 2 gives us, now this is 4.5. 4.5 is minus 9 over 2. Because we just multiply this 2 there, it's going to be 8 plus 1, that's 9. We drag the negative, so this is minus 9 over 2. Okay, it's better that way. So we want y at P minus y at K, which is minus 4 divided by 2 should be equal to minus 6. Now the gymnastics here is just to cross multiply the 2 and then transpose the other one. So when you cross multiply there, there's 2 divide out, and so we end up with 9 minus 2, which is minus 11. Minus 9 minus 2 is minus 11. Same gymnastics here, we cross multiply there and then we transpose. What do we get? This is minus 12 plus 4, it gives us minus 8. Okay, we've got the coordinates of P. Of course, what we were interested in is nothing but the x coordinate. We're not interested in the y coordinate per se. But at this stage, we have to show both because this is an ordered pair. Now we can answer the question. Then, area of triangle LPK is going to be half base times the perpendicular height. This is going to be half the base here. We're going to take the vertical one, right, which is going to be y at L minus y at K into, now the height here is going to be the difference of the x values. It's going to be x at K minus x at P. I'm just showing you this. You may not need to write that formula there. You just go in and substitute. So y at L is 28 over 3 minus y at K, which is minus 4. So it's going to be minus 4, which is going to be plus 4. Into x at K, this is 2 minus 11, going to be plus 11. Let's see what we get. Now we can just put it on the calculator. 0.5 into 28 over 3 plus 4 into 2 plus 11. So I'm going to round off to 2 decimal places. This is 86.67 units squared. Okay, this is one of those, higher grade type questions, because here you only survive if you know your work very well. If you don't, you lose out on this one. Okay guys, so this is not too complicated. How do we score these marks here? 7 marks. Yeah, that's quite substituting these things right here, very important. this one right here, very important. And knowing that the x-coordinate is that, I suppose, is good. Here it's just the substitutions and the answer. So 1, 2, 3, 4, 5. Then 6. Then these are calculations, or we can just say substitutions. Fine, 7. I don't know how these marks come about, but this is how I would distribute them. You know. All right, okay, all right. So let's do the last one here. 4.3 says another circle with equation -2 plus y minus n equals 25, okay, is drawn. Determine with an explanation. Can you see? Determine with an explanation. This is yet another hard hitter, which says, oops, sometimes, you know, this thing just wants romantic things. Okay, with an explanation, the values of n for which the two circles will touch each other externally. Okay, all right, okay. So now this is a question that says we need these circles to be touching, maybe like so. Right. So they can touch like this, right? And this other one, right, so they can touch like that. There's many things. Of course, we look at what that value is. Is it a y value? So if this is the y value, it literally says I have not represented my stuff properly. So it can only be on the y, right? It could be stuff like this, because n is going to be the y value. Could be something like that. I'm not so sure what I'm doing is right, but I'm thinking about it now on the fly. So, hlanyisa wena. Sikanketsa jwalo wena man. Hlomong it's like this one. Maybe we should remove this. Doch. Anyway, I wanted this thing to come up here, right? So maybe it's like this or like that, because we can see n is on the y values, so it should be the vertical type of touching that is special. Why? Because we see that the x1 is the same. It means what is the center there? So the center is more or less the same in terms of the x coordinate, but we can clearly appreciate the center of the other one is a bit off the center. So this suggests that the center of that one is also the line that is collinear perhaps to the center of the other one. You know, maybe like that. And same story there. Same stories. It means the center of the other one, perhaps, and the center of the other one. Okay, this is something like so. Now we need to work out the y values for this to be the case, to determine. Of course, it says with explanations. Wow. Okay. For the two circles to touch each other externally. So, yep. But now, What happens if we say these circles are like this? What is that? What about that? Is it not possible? Yeah, this is internally and this is externally. My Lord, okay, I am wrong here. You see, sometimes thinking again is good. Because remember, you must always think of possibility. This is touching internally what I showed, which is technically wrong. So the story being transmitted is this one. That these ones, of course, this is going to be the other one. And then this is going to be the other one. No, man, don't be kind. Hey guys, I'm wasting time now. I was doing well, but now I don't know what happened. You know, sometimes you just do well and then things just go wrong. For some reason. Don't like crazy explanations when hey, I'm you see doing other things now. I want to copy this one this time. So could be stuff like this, it could be stuff like this. I'm just thinking on the fly because technically the x-coordinate of the centers of these two is the same, you know, because if this is the center of the other one, this is the center of the other one, and this is suggesting that these centers are collinear. They are collinear vertically. Because we see this one. And the same thing here. The small one is on top. Sonhlanyisa wena. Skanhlanisa wena. Tlonkudisa jwalo, tlonkudisa wena. Batlokola nna. Haona ditlhare mona. Okay, so this is the story, guys. So yeah, these questions, they irritate me because why must we suffer, man? Why must we suffer or suffer? But we know that we've got two possibilities. It's either the bigger one, because this is already, okay, not big, but it's the same size actually. I don't know why I made this other one small. It's the same size, so we know that, okay, all right, okay. What the suggestion is that this other circle is literally this circle, but I'm gonna make it smaller, let's leave it. But now we know that this vertical line is the one because the x-coordinate is the same of each of the centers. So it's either they are on this line, right? Such that the other one is here. The other one is here. You know, the other one is over there. Or it is over there. Right, but what we know for sure is that the centers are on this vertical line. So this is the center, and that is the center. So the centers have the same coordinate, which is 2. What differs is the y coordinate. So this is why we know they sit nicely like that. Okay. Of course, because these are just sketches, for sure we can do the things. Of course, guys, this is just for me to demonstrate what we are dealing with. Otherwise, you don't really need to do this per se. But you need to understand this is this. This is this. All right. So now what are we going to say, guys? We know that they have the same radius from this business right here. R squared is 25, so it means each one has a radius of 5. Okay, all right, okay. Okay, so we understand then when these two touch externally, you know, when these two touch externally, what do we know? We know that the distance between their radii is the sum of the radii. Right. So this means we need to know this center is going to be 2 and. Now remember, we're going to take this down 5 units to here, which is -4. And take that again 5 units down. -4 minus 5 is going to be -9. So we need the center right there. And we take this up again. It's going to be 5 units up. So when it goes up to here, it's going to be 1 plus 5 because we're moving it up. It's going to be 6. 6 plus yet another 5 here. While we know that the center is 2 and. Now what did we say again? It's going to be 1 plus 5, that's 6, plus another 5, that's 11. So that's the story that we get. Nice and easy. So these questions, without a thought, believe me, you're not going to win. And mind you, this is just a framework of how to solve. As you can see, this 4 marks is time consuming. You may want to skip this thing and go and chow other questions before this wastes your time severely. But now I'm reviewing to try and teach at the same time. If you see this long before your next exam, especially for the matriculants of 2025, this is good for preparation for the trials and finals. Because I'm doing these videos early so that you can have enough time to see the strategies, the techniques and planning. Then you get used into doing this so that you can learn to do it faster then. Anyway, guys, so what are we going to say? Remember, these explanations is to find the centers of these two circles. The explanation is definitely doing that. And I don't know how we're going to phrase it, but we need to say the centers are like this. From the centers, we can be able to, because these are the values of n, right? N can be basically here plus 9, or say minus 9. Minus 9 is going to be plus 9, or 11. So those are the two values basically. But now we need to justify how on earth are we going to get these things. Okay, all right, okay. So we need to state that these circles have the centers that are on this vertical line. We need to say that. How do we know? It's because the x-coordinate is the same. We should know that. So we will start there. So, okay, 4.3 is going to say, well, sorry. So we can say these circles will be such that what can I say? What can I say? Yeah, God, losing time and I'm not moving. It's the last question. We can say here the circle centers. You can say circle, or the circles centers lie on, what did we call that line? LMK or KML. You can say KML. Why do we know this? It's because the x coordinate x coordinates, the x coordinate for each is the same, which is equal to 2. Nice. Okay, all right, okay. So what does this mean? It implies that the centers of the new circle are such that it is 2 is 2. We take 1 from the other one, we will add 5 plus 5, and this one is going to be 2 is 2, 1 minus 5 minus 5. We can say therefore the centers of new circle are 2 is 2, 11, and 2 is 2 minus, of course this is minus 10 plus 1, which is minus 9. If this is the case, we can say therefore n is equal to 11, or n is equal to minus 9. Don't worry about the sign doesn't matter. What matters is the value of n. I don't know, guys, this is the best I can say, you know. Before we can justify this part, why did we add 5s and subtract 5s? We can say again they have the same ready. Okay, they lie on this line and have the same ready. Maybe let's just move this down a bit to showcase everything that we're doing nicely. We can say and have same ready equal to the square root of 25, which is equal to 5 units. Okay, try to be as elaborate as you can, guys. So I don't know how these 4 marks are going to be scored, but I think the most powerful here is this, guys. 2 marks there. And then perhaps for the first part here we can say a mark, and for the second part here perhaps mainly this part right there, those coordinates of those possible coordinates of the centers, I would suppose they get a mark, half a mark each, or a mark in full, or one can get, the distribution can be made into any other distribution, of course, knowing what you need to know. So I'm just bunching everything together so that we don't end up, you know, perhaps let's just not be naughty here and say this whole thing, because it explains each other, whatever seems to be more important. So what matters here, guys, is the centers, because once we find the centers, we have found the values of n, because they are part of the y values of n. But we start here and say they lie on that line. How did we know? It's because of the x coordinate for each was the same, and it was 2, and we got it from there. And then we know that the radius is very important also in showing us those shifts vertically. and we're shifting it twice because we can see for this to touch externally, they need to look like that. So a bit of framework to the solution, guys, and trying your best now to figure it out. Finally is great. So this was the grade 12 question is always challenging, and it's more time consuming than the first one usually. Get used to it. Okay, let's get to question 5 and start moving as fast as we can. Okay, question 5. So guys, I've given you some nice revisions on trigonometry, which if you have learned, you should not struggle too much. So 5.1 says, without using a calculator, we need to write the following expressions in terms of sine 11. Okay, so not a big deal. So we have 5.1.1. So sine 191 degrees is equal to sine, we're going to use reduction formula. It's going to be 180 degrees plus 11 degrees. Right, which is going to be equal to minus sine 11 degrees. Okay, all right, okay. So that's easy. 1 mark from the reduction, because that's what gives us the marks. 5.1.2, we have cos 22 degrees. This is the same as cos of 2 times 11 degrees. So we need to sort this out. Best thing is to use 2 cos squared 11 degrees minus 1. Or you can choose the sine, or both sine and cos. It's not a big deal. So here you've got options of presenting this answer. This is good. I would stop here because it's just 1 mark. But a student can write here cos squared 11 degrees minus sine squared 11 degrees. Or one can write 1 minus 2 sine squared 11 degrees. These two possibilities are essentially acceptable as long as we finally deal with the issue. Okay, this is not the final answer, so if you present that, you don't get a mark, okay? Please. So there is our mark. Or it can be any one of these two replacing there. Not a big deal. So let's do 5.2. We need to simplify this to a single trigonometric ratio. Easy. 3-step approach. Cos of x minus 180 degrees plus the square root of 2 times sine x plus 45 degrees. Okay, this is going to be equal to, now reduction formula, what is x minus 180? Where is this? This is as good as minus 180 plus x. So this means we're in the third quadrant. Cos is negative here. So this is minus cos x plus root 2 into, we need to expand this. So this is going to be sine x cos of the second angle. The sine remains, then it's going to be cos of the first angle, sine of the second angle. Right, so this is equal to minus cos x plus square root 2 into, now cos 45 is 1 over root 2 sine x plus, again this is going to be 1 over root 2 cos x. Now we sort it out, we distribute the root 2 So we will see that we get minus cos x plus this goes, it leaves us sine x, and that goes as well, it leaves us plus cos x. And guess what? These are like terms, they cancel. So what do we remain with? Sine x. See, not so very difficult, but a bit technical if you're not very careful. And of course, guys, you can just choose to check if this reduction is good. Just say x is equal to 2 degrees. And use the calculator for that question, because there was no saying without using a calculator. It wasn't said. But obviously simplification means we need to see the steps, isn't it? But we just want to check if our simplification is good. Let's just say sine 2 degrees. What is it? We get, for example, for this final answer, we get 0,0353 to 3 decimal places. Now we want to take it in there and see what do we get. So we're going to have cos of 2 minus 180 brackets plus the square root of 2 into the sine. Be very careful here of the brackets because they can be a disaster. 2 plus 45. And please make sure that things are done properly. And guess what? I'm getting the same answer of 0,035 to 3 decimal places. So can you see, I know my reduction is good. Once I can assign values and then I get the same answer for the first, the original, and the simplified version, then I'm winning. I'm winning. Of course, guys, there's no need to not know if you are winning or not in questions of this nature. I've shown this multiple times. So please win, don't lose. Right, so this reduction, remember 3-step approach, excellent. This expansion using the compound whatever, then special angles here and here. 1, 2, 3, 4, and the final answer 5. We are good. Of course, these marks can be distributed however the examiners chose, as long as the steps are shown and you get your marks. Of course, sometimes you may want, okay, don't skip steps. Let me not even entertain you guys skipping steps. Okay. All right. Okay. So we have, okay, maybe this one is going to be a bit hectic. Let's just do it alone. 5.3, we are given that sine P plus sine Q is this situation, and then P plus Q is 90 degrees. Oh, now this is a higher grade question for sure, and it begs some understanding from a student. It says, without using a calculator, my lord, we need to determine the value of sine 2p. Okay. So now this is a very technical question. If you look at it, it's not nice, it's not good, it's not great. But of course, we can see that the left-hand side has sine P and Q. So that means we can actually express Q by P or P by Q here. And we will get co-ratios. So it's not too bad, isn't it? So this is suggesting as much. Then what are we going to do with this now? Where does this come in? Well, we will see what happens. So I can already see that if this is in terms of sine 2p, I need to get rid of Q and make it in terms of P. Maybe that's going to work. So let's start sine P plus sine q is 7/5. Right? So this implies that sine p plus sine, instead of q, we're going to write 90 degrees minus p, isn't it? But just solving for q in terms of p equals 7/5. Right. So this implies that sine p plus, now this changes to cos p, is equal to 7/5. Now sine and cos of the same angle when added together is not what we like sometimes. So if we don't like it, what are we going to do, guys? Sometimes that, okay, this is irrational. So I don't know, not necessarily irrational, but if we can square both sides, we can get something, identities coming up. So be very experimental. Of course, you don't know if it's going to work. So you want to start this on rough work before you do this here. Because once you get here and you're stuck, take your rough work and do this thing. And if you feel it's working, just say CRW from there. You'll be marked where you're supposed to be marked. So we get sine squared p plus 2 sine p cos p plus cos squared p equals, this is going to be 49/25, right? Now you can clearly see we created a double angle identity expansion of sine, and it's exactly what we want, because guess what? These dudes are like terms. Sine squared of the same angle plus cos squared of the same angle is 1. So we know that we've got 1 plus this, we shrink it, or we contract it, it becomes sine 2p is equal to 49/25. I don't like the drift hood too much. It's not impressive. Oh, don't do it. O don't silly ka wena. Skantena. O nahana hore ke diphahlo jwale, wa ntena jwale. Hobane o ntena. Kampa ha o ntshabe. Ke tsela ya hao ya o njwetsa hore ha o ntshabe nna. Tshwanetse re ntshabe he, hobaneng ke kotsi. Ke kotsi hampe. O tlo ikutlwa e ka ba o bitsa ba haeno. Ha ba batla ho lwana le nna, 49/25 is greater than 1, so it can take 1. Therefore, sine of 2p, we multiply there. 49 minus 25 is going to be 34. Is it 34? Is it 14? Hey, angisayiqondi kahle ke ngoku le nto. Ngubani ke ngoku masisithi 49 minus 25 kaloku is 24. Ayi kutheni ningakwazi ubala nje ngoku all of a sudden is 24/25 ke guys. Kodwa xa uthanda ungavela uthi 49 divided by 25 bese usithi minus just 1. Iphinde ikhuphe njengoba injalo. Siyigqibile ke ngoku. Gqibiyane. Yayibona? So this means if this worked on your rough work, all you simply do from this step, you just simply say CRW, the continuation there. But make sure it's marked properly. So this was a nice question. Please, guys, know the gymnastics. This is algebra. Okay? All right. So this is irrational, literally, because P can be any angle. So it can be irrational. It can be rational. So think of trying to rationalize things, most in a way, kind of, sort of. Because irrational multiplied by irrational is going to be rational. This is squared rational. This is squared rational. You get it? So we think of just rationalizing, or sort of like radical equations. Anyway, guys, sigqibile asifuni besithetha kakhulu. If man, how do we score these marks? For sure, showing this up like so is good. That reduction is good. Now that's 2 marks. The gymnastic of squaring is the 3rd mark. Now getting this business here using identities, that's 4th. Vethu sithe zaphela ngoku-5. Andingaqhelwa kabi ke. Khona abantu abafuna uqhelwa kabi. Tyhini, bandihlolela. Andifowunela ngeli xesha ngoba kwenze njani. So this is 1, 2, 3, 4. Of course, whenever we use identities, guys, we get marks. So this is 1, 2, perhaps 3. Okay, this one is definitely a mark. So 1, 2, 3. Shall we say 4 for the entire thing? 4, maybe. These guys must not be crazy, man. Hey, why are they calling me now? I'm not on duty tonight. Lord have mercy. People are trying to mess with me now. Anyhow, 1, 2, 3, reduction 4, good. And then maybe 5 here. We can leave the gymnastic, but it may get a mark. That may not necessarily get a mark because this is purely given, guys. So I would say maybe the gymnastic here, because it's not so obvious, isn't it? Squaring is key here. Okay, that's how we score those 5 marks, guys. Easy 12 marks here. What I like is that these questions are not too difficult, but they're technical, which is what makes them higher grade questions. So let's get to some more trigonometry. So dealing with trig functions. Okay, all right. Okay, so question 6. Question 6, we know what to do. 6.1, we need to find the general solution of this situation right here. So this is not a big deal. Cos of x minus 30 degrees is equal to 2 sine x. So if I ask you students, what are you supposed to do here? Do not flip and expand. If I was to use the incorrect language here, do not flip and expand. If you do that, you're going to get stuck and cry. But if you know how to handle it, you can, okay, smartly so. But sometimes it doesn't really yield good results. So this is equal to, we leave this one alone, but we can change the other one to what? To sine. Is it sane? Is it sane or is it sine? You see, the problem here now that I'm seeing is the fact that we've got a coefficient. So yes, a coefficient demands a different approach now. Because 30 degrees is a special angle, so we need to expand. Oh, shame. So this is cos of the first angle. Cos of the second angle, the sign changes to sine of the first angle. Sine of the second angle equal to 2 sine x. Okay, all right, okay, so we're seemingly doing great. This implies cos of 30 is root 3 over 2 times cos x plus sine 30 is a half. Sine x is going to be 2 sine x. Okay, so this implies further that we've got root 3 over 2 cos x equals, why don't I just rearrange? Because I can see I want the tangent coming out here. So I'm going to say 2 sine x is going to be equal to, no. So we can say 2 sine x minus, we transpose this, half sine x is going to be equal to root 3 over 2 cos x. So all I did, I just took this and transposed it to that side, but I just rearranged it so that it follows the way I want it to. So here we multiply the 2, it's going to be 4 minus 1 is going to be 3 sine x over 2 is equal to root 3. Perhaps let's do it this way. Factor out this. This is going to be 3 over 2 sine x divided by root 3 over 2 cos x. Now I can divide by anything I want, but I want to eliminate this from there while I want this cos underneath so that I can have a tan x. So the best thing to do here is to divide by 3 over 2 cos x. Remember, in maths you can divide by anything you want. So I've got 3 over 2 sine x divided by 3 over 2 cos x equal to root 3 over 2 cos x divided by so we can say root 3 over 2 cos x divided by 3 over 2 cos x. Now we want the magics to magically happen. So we know that this implies that tan x is equal to, now this one will flip, it's going to be basically root 3 over 3. Exactly. How to see check a foot. Root 3. Hey. Root 3 over 2 divided by 3 over 2. Yeah, it's root 3 over 3. So which implies, in fact, for 10 we don't need a lot. We can just simply say x is going to be arc 10 root 3 over 3 plus k times 180 degrees, where k is an element of those guys called integers. Khona into engayithandisisi kodwa ke sendiyayamkela. Therefore x is going to be equal to arc 10 root 3 over 3. Wow, 30 degrees bendingayazi. All right, okay, so this is 30 degrees. Wow. And by the way, okay, no one told us about calculator business. Now, this general solution is good. You do not need the one in the third quadrant where you're going to say 180 plus 30. Even if you wrote it, it's okay, but there's no need. This repeats 180 degrees, so it's already there. Oh yeah, here, once there's a coefficient to the other, yes, we need to expand. If there is no coefficient, don't expand. I guess that is where I got caught, pens down. Now 6 marks here, so technically the expansion, nice and easy. Using the special angles, nice and easy. And using the gymnastic here, perhaps, I don't know if it matters, but I think identity is nice and easy. General solution, nice and easy. What else? So 1, 2, 3, 4. We need 2 more marks. 2 more marks. Okay, I guess we can get that one. And perhaps the division here, this step perhaps deserves a mark, I suppose. Again, the examiner may decide where these ones go. Okay, all right, okay. So 6.2. Now 6.2 says in the diagram, the graphs of the very same functions are drawn in the interval minus 180 to 180. A and B are the x-intercepts of f. Okay, so we see you and we see you. Now, what do we know? F is this function, 30 degrees. So cos has x-intercepts at 30 degrees. At 90 degrees and minus 90 degrees, about the maximum. But now we shift this to the right 30 degrees. So this means it's going to be 90 plus 30 degrees. So the coordinates of A are going to be 120 degrees and 0. Because 90 plus 30 lands us at 120. Again here, this must have been at minus 90. Then we're going to add 30 degrees. So this is going to be at minus 60 degrees. So again, guys, knowing how these functions work, it's going to be good. Just know how things will shift around. And of course, D is the maximum right here for this function. So what should be the coordinates of D? Remember, this was supposed to be 0. Then we delayed 30 degrees. So it's going to be 30 degrees is to 1. Right. Because 30 minus 30 gives us 0. Cos of 0 is 1. So good. So sometimes you get some coordinates nice and easy, and then you know what, you get moving. The 2 graphs intersect at C and D. We see you. Okay, we already have the coordinates of D now. And we are told the minimum and the maximum turning points respectively of F. Sorry, C and D. Oh, yeah. Okay, if this is the minimum now, this is already giving us the coordinates also here. Ah, man. Skantina. O batla ho nkira biana biano. Hobaneng o nkira biana biano. I am laughing, but I'm not laughing exactly. So, now remember, this is in the 3rd quadrant, literally, because remember, this is the 4th quadrant from here until 90. Then from minus 90 to 180, that's the 3rd quadrant. So now in the 3rd quadrant, what happens? When do we get to a minimum? So this should have been at minus 180 anyway, right? But now this shifts 30 degrees to the right. So minus 180 plus 30 degrees takes us back to minus 150. So this is exactly at minus 150 degrees is to minus 1. Yabona imaths xa uyazi ke mntana esikolo uvele nje ube ngathi ngumthakathi. This is minus 150 degrees and minus 1. So when you know maths, you look like a witch or wizard if umuntu ongumama. Okay? Xa umuntu ongutata kuthiwa uyi-witch, mthakathi. Xa umuntu ongumama kuthiwa yi-wizard. NgesiXhosa simthakathi zonke okanye simthakathikazi. Kodwa xa ufaka ukazi esiXhoseni ubukhulu becala uyayibaxa. Okay? Uyenza ibe nkulu, bengathi ngumthakathi omkhulu, umthakathikazi. Kodwa maxa wambi ithetha isikhomokazi, which is feminine. Yayiva yengulento. Yo. Funda nesiXhosa nesilungu khona apha. Bendingayazi njalo lento. Kaloku i-mathematics lulwimi special. It's a special language, this subject called maths. So yeah. So can you see, guys, we know things by just looking at things. We don't even worry about, working out x-intercepts and what. We just know. If it was meant to be here, it shifts. If it was meant to be there, it shifts. Like that. Great stuff. So here, the sine one is not a big deal because yona, sine agachinchanga, right? Sine agachinchanga yena. Sine didn't change over. There are no water there. It's not water. It's not holding there. So the sine one is changed over. Alright, guys. So technically, this should be exactly at 90 degrees. This one should be at exactly minus 90 degrees. Azenza baphoxa abantu abandifonela ndingekho on-duty bandihlolela nkosi yam. Inene bandidakelwa, yazi bangidakelwa la way. Tyhini. Ngifuna ukuqhelwa kakubi ke tana. Because andifani ninyakanyaka. Anyway, anyhow, siqhela kanjalo, masiqhubeke. Ithini ke ngoku lento? Ithi lento siyawina. Eva ke ngoku siyawina. Of course, this is a half cycle. The coefficient is 1, so the sine graph doesn't change. It's just amplified vertically. See, stretch it vertically because the amplitude now is going to be at 2, right? Ndicela nizazi izinto bantwana besikolo. Ngoba you will win easily if you know these things. Kodwa, if you don't know them, you're not going to win easily. So this goes to 2 minus 2. Okay, this one and that one. Yabona? Siyawina. Inkomo zasekhaya ndisengumancane. Ndandizibize ngo-Z ngoba igama lam liqala ngo-Z, yayifumana. So nguziyawina. Oyena wayi-ancestor yazo zonke ngelaa xesha ndasendibhadlile. Kodwa zazininzi ezinye ndandizazi before that. Kodwa kwaba nguziyawina, kwaba nguziyathelela, kwaba nguziyawela. Then enye ke ngoku ezezinye ndazibiza amagama esingesi nasendifunde nango-oxygen. Ithole likaziyathelela lokuqala ndathi ngu-oxygen, elesibini ndathi nguziyawela. And then elikaziyawina lokuqala ndasendifundile ngenkonzo. So akhona uncinci behlala besithi baya kwi-mission yaseWesile. So ndathi la elathole lokuqala, phofu not lokuqala, elokugqibela ne. Yeah. Mission ngoba lithole lokugqibela likaziyawina because uziyathelela wayezalwa nguziyawina actually. And zazithiwe ndim zonke izinkomo except uziyawina, of course. Athi ngumishini. Yo. Anyway, anyhow. What do we say now? We say things. Can you see we worked on this graph like there's no one trying to mess with us here. We worked on it like nobody's business. Now 6.2.1 says we need to write down. Can you see, guys, the instruction is to write down. Please don't be explaining. Asochaza apha. The question xa sithi bhala bhala amabhalane sisichazela sifuna ukwazi siyayazi into esiyifunayo thina. The coordinates, yabona xa kuthiwa coordinates siyifuna laa nto i-ordered pair. Sisamgqiba kudala u-A wethu besithenga ubani kanene? Sithenga 120 degrees and 0 bese siyibonile. So this is A, this is A, this is B. Those ones of C is for many now, so it's minus 150 degrees and minus 1. Yabo? Siyakruza abantwana besikolo, siyakruza 6.2.2. Again, kuno A phayana. Ithi ke ngoku into determine. Now determine is open-ended. The values of x in the interval for which both graphs are increasing. Okay, easy stuff. Now let's see. If the two graphs are increasing, we expect positive gradients. Now you can appreciate that this is this minimum to that maximum. And then, of course, this one starts from this one until there. Because we want the overlap. Perhaps let's just do it nicely and say this one is doing like that. It's increasing between those turning points. So now where's the overlap? Right here in between. Okay, all right, okay. So again, we can do it by inspection. So we know that technically here, the x value here must be less than. Remember, the other one is neither increasing nor decreasing at the turning point, meaning f. So we cannot include that value. So it's going to be 30 degrees greater than, because again, at minus 90 degrees, G is neither increasing nor decreasing as much as that one is increasing. But here we're saying they must be both increasing. So this must be greater than minus 90 degrees. So of course, guys, we get our 2 marks here. We get our 2 marks, and then we get our 2 marks there. This one is 1 mark, okay. So 6, okay, B says now f of x plus 10 degrees greater than g of x plus 10 degrees. We know that the plus 10 is a horizontal shift of both graphs to the left by the same don'ts. And of course, folks, when are they greater? When is f greater than g? Look at f. F in this interval is above g. But now this is between D and C. Then it means we're going to shift the coordinates of D 30 degrees to the left. 10 degrees to the left, as well as the coordinates of C like that. So this means this becomes now, if we're shifting to the left, we're going to say subtract. So minus 150 minus 10 degrees is going to be minus 160 degrees. But the y remains. It doesn't change. And then also, we will change our D to, we subtract 10 here, we get 20 degrees is to 1. So that's what we need to do here. Should have been more marks though. I'm not happy. So we know that x here must be less than 20 degrees greater than minus 160 degrees. Why? Because at those 2 points, they are equal, so we cannot include. So it has to be in between, because f is greater than g. But beyond D, G is greater than A. And beyond C, or before C, we see that also G is greater than than F. Okay, so that's easy, guys. Not a big deal. Again, 2 marks for the notation and everything in there. So we've got 6.2.3. Now this is a higher grade question. It always is there. No matter what question we are answering, there will always be a higher grade question. We need to determine the range of this business right here. Okay, how do we handle this? Of course, we need to focus on the exponent. Why? Because the base is a constant that we cannot worry about. It remains whatever it is. The maximum of 2 is 2. So for this to be a range, meaning maximum and minimum, it means our job is to find the maximum and minimum of the exponent, because it is variable. In a variety. So understanding the question, guys, makes you the winner. But now I can tell you that 2 sine x is actually the graph of g shifted 3 units upward. So this means we're going to take the maximum. Sometimes they like to say use the graph to determine, but sometimes they just let you be. Whether you do it algebraically, whether you use the graphs. But what is nice is that the maximum of 2 sine is 2. Then we're going to just add 3. It becomes 5. The minimum was minus 2. We add 3. It goes to 1. You see? You see? You see? So, of course, the question said determine, but for 5 marks, we can't just write the answer only. It means we need to find the maximum and the minimum. Once we get those values, we then include the base to those things and then find the actual. So it's going to be quite an interesting, if not interesting, situation. All right, okay, all right. Now let's have a look here. How we start here, we can say here, the maximum of 2 sine x plus 3 is going to be equal to 2 plus 3, which is equal to 5. And minimum of 2 sine x plus 3 is going to be the negative absolute value of the amplitude. So it's going to be minus 2 plus 3, because that's the necessary shift, takes us to 1. Now once this is done, we can say then the range of y equals 2 to the exponent 2 sine x plus 3 is equal to a set of y values such that y is less than or equal to, remember it includes the maxima and minima, so it's going to be 2 to the exponent 5 greater than or equal to 2 to the exponent 1, which is just 2. But remember, that's not it. So we can say, therefore, the range is equal to the set of y values such that y is less than or equal to 2 to the exponent 5 is 32, greater than or equal to 2. Seyigqibile. Riqedile. Siyiqedile ke goje. Ya, siyathi thina letibalo leti. Yalibona ukuthi lena lirobele lapha. Torobala. Imbalitieke esikoleni lakhe still tobala konje liyarobala lona. Dilekudlala kuyalibona. Yes, if you didn't know, that language is called Siputi. Hello, Naskantina. Hey guys, why are those people calling me now? Here, why are they calling me, man? I'm not interested. You see? Anyway, folks, this was a nice question, and you can appreciate that functions are very, very, very interesting when you understand them and you just start enjoying things. First of all, folks, this maximum is great. This minimum is great for this function. So, of course, we understand that from the graph, guys, these values are coming from the graph. It's not the graph. Maxhosa. It's not the graph, it's the graph. Okay. Sanuthetha ngegraph. Siyazi draft. Sazi igraph, ne? Masingaqhelwa nini nisincede. Siqhela kabi nini. Now, injalo ke bafethu. Kodwa ke ningathathi offense yayifumana mina ndiyazincokolela mina. Ndiyanazi ngamagwala kabi. Bayithetha qatha ndifuna ukukhala. This one is angry. I'm not angry, man. And I'm also not naughty. At the same time, I'm not obnoxious, but you may want to look at me that way if you will. But hey, I'm not going to stop you. Right. So basically, this one and that one, because we needed the answer, right? We did need the answer. So that's like 4 marks, ne? Yeah, that's like 4 marks, Moss. That's like 4 marks, Moss. Sometimes you may want to say, I'm giving it here. Or I can say the set built notation as a whole, because this is a language. It looks more mathematics, Moss. If you start writing, yeah, let's leave it at that. It's like that. Of course, many of you would want to write that y is an element of these intervals, but remember these are included. So this is 2 and 32. Of course, the whole workings could have been used like this. Interval notation is all good. Or just simply the inequalities. Not a bad thing, but I like maths to be written the right way so that we read the maths, not the nonsense. Okay. Anyway, guys, must begin. There's a 3D stuff. Must be fast, so that we can enjoy our Euclidean. Is it Euclidean or is it Euclidean? Because this, guys, there's what we call U. Now, this is sort of like U. Either U like this or spelt like you would call a U. But when you see Eulers, is it Eulers? They call it Eulers now instead of like Eulers. Why Eulers now? What does it Euclidean? Why don't we say Euclidean geometry? Yabona amagama enwabiza sisigrike phela isibanye sisilatin, whatever it is. Anizoyitshintsha indlela eqala ngayo iroot ne sanusigezela. It's Euler. It's Eulers. It's Eulers. Hey. Anyway, guys, that was a nice 18 marks, guys. So you can see this can give you confidence or it can break you apart if you don't know your story, by the way. So you need to recognize. Question 7. Got in Jonga something. Anyway, I was just checking my roster to see if I'm on call. Because these people are just calling and I don't understand. Alright, in the diagram below, CGFB and CGHD are fixed walls that are rectangular. What is it called? CGFB and CGHD. So these are fixed walls. Alright, okay, alright. So we can simply see these are walls and that's the horizontal plane. But now we're looking at it as if X-ray. Okay, that are rectangular. So the good thing is if we're told the kind of shape, It means every angle is 90 degrees, bafethu. Sanuyilibala loo nto. Ndiyanazi ningabantu abalibalayo, ningamaxhegwazana amancinci nje namaxhego amancinci. Lesikaba amaqhego le maqhegwazana ka mona. Letletse ho dlala, le ska tlo dlala mona. Hantle ntle, ba re jwetsa hore those angles di khoneng ka mono. Ke di 90 degree angles tseno. Re di etse be kgolwanyana ka mane. So what do we know about a rectangle? The opposite sides are equal and parallel. Are they parallel? They are parallel. And so technically, if that is the case, this is the case. So this means these are congruent rectangles. Load of loads. Anyway, anyhow, let's just put it down here so that the notation doesn't look strange. Okay, these are all parallel like so. But now the lengths are not the same. Oh, this one is longer, this one is shorter. That was the catch. But if that is x, folks, this must be x. If this is x plus 2, that's x plus 2. We're going to use that notation instead of these others. Of course, they are parallel. They are parallel. That one is parallel in a different way to that one. So we must just try to be like the way we should be. So, not a big deal. Exactly, in a shape and vertical to the horizontal plane, FGH. Where is FGH? FGH, okay, that's the horizontal plane. Now, still poles erected along FB and HD extend to A and E respectively. We see this. Now, triangle ACE or ACE forms the roof of an entertainment center. Triangle ACE forms the roof of an entertainment center. Okay. Now BC is X, CD is X plus 2, BAC is theta, BAC there is theta, and ACE is 2 times theta, and ECD is 60 degrees. So all of these are indicated. We don't need to worry about it. Now let's start 7.1 with 7.1.1. We need to calculate the length of AC in terms of X. AC in terms of X. So guys, this is the triangle. It's a right-angled triangle. So we want AC in terms of X and theta. So what do we need? Well, this is the hypotenuse side because it's opposite the right angle. And we've got the opposite side X that becomes the angle. So this is sine theta. So we can say in triangle ABC, we understand that sine of this angle BAC as it was given should be the opposite side, which is BC, over the hypotenuse side, which is AC. So this implies that sine theta is going to be BC is X over AC. Cross multiply AC and divide. We can say therefore AC is going to be X over sine theta. Nice and easy. So just 2 marks, guys. Substitutions and the gymnastics leading up to the answer. So we have 7.1.2. We need to find CE in terms of X as well. CE in terms of X. That's not a problem because we got another triangle. So we've got another right-angled triangle. Everything was indicated. We've got the adjacent side. We want the hypotenuse side. So we can say in triangle C, D, E, we understand that the cosine of angle ECD should be the adjacent side CD over the hypotenuse side, which is CE. This implies that cos of 60 degrees is equal to CD, x plus 2 over the hypotenuse, which is CE. So we continue. Cos of 60 is a half from special angles. This is x plus 2 over CE. And we can cross multiply here. So we can see that CE is going to be equal to 2x plus 4. This one is not 2 marks though, guys. Are you serious? This substitution special angle, guys, come on, this is 3 marks. Sengiqala kodwa ke bazama ukuthi komuntu onendaba nani apha mhlambe leni too obvious, mhlambe that one. Naleyo singayamkela. Okay, to show that the area of the roof triangle ACE is given by this situation. Okay, not a problem. Okay, so let's just say area of triangle ACE is going to be half AC times CE times the sine of angle ACE. That's the area rule, isn't it? Which is going to be equal to half AC is x over sine theta times CE. This is 2x plus 4 times sine. Of course, let's make it a fraction over 1 times sine of 2 theta. Right. So this means we have a situation that we have a half here into x over sine theta into 2x plus 4 over 1 into, this is going to be 2 sine theta cos theta using identities, and this is all over 1. So if we conveniently multiply that first one and that last one, this guy and that guy will go. And if we take this second one and that one again, this guy and that guy will go. So what do we end up with? So we end up with essentially I can go. We end up with x into 2x plus 4 times cos theta. Then we factorize here by taking the highest common factor. It multiplies the factor outside. So we end up with just x plus 2 times cos theta. Okay. Not a very difficult question also. As long as we know what to do, but be careful, be careful. You need to be smart about these businesses. For me, writing the rule in terms of the triangle is good. Substitutions, because we're just scoring 3 marks, so not big, but here doing the expansion here of the identity, we always get a mark. Now factorizing in the last step, taking out the highest common factors, what is key? The substitutions are pretty obvious, but they are an option for giving some marks. All right, now let's do 7.3. Now 7.3 says, if theta is this, BC is that, calculate the length of AE. We want AE, of course. What do we need? So as you can see, this is usually an easy question, but this has been made a bit challenging in that we're being told BC is, so it means X is 12 meters. So that means we use this triangle still, but we need the cosine rule here to get around business, because we want the length of AE. So we know that AE, okay, maybe let's do this in triangle. In triangle ACE, we know that AE squared is going to be AC squared plus CE minus 2 times AC times CE times the cos of 2 theta. But now we can say cos of ACE. No, don't know what I'm doing there. Yeah, because of the included angle. So this implies that AE squared is going to be ACE. Now we know that AC was X over sine theta. So this is X. Now X is BC, which is going to be 12 over sine theta is 55 degrees. All squared plus CE. What did we get? This is 2 times 12 plus 4 all over 1. Okay, squared minus 2 into 12 over sine 55 degrees into this is going to be just 24 plus 4, which is 28. Okay, let's just show this one is 2 times 12 plus 4. 2 times 12 plus 4 all over 1. Okay, let's just move it a bit. The drifting is unavoidable now. Okay, we can still handle it. So this is times cos of 2 into 55 degrees. Okay, nice and easy. So this means that our AE squared is equal to, so I'm not going to waste time here. Now I'm going to go with the flow. So we've got 12 over sine 55, right, all squared. Now know how to use the calculator well, guys, or else you will be in trouble. So this one is as good as 24 plus 4, that's 28 squared. Okay, minus 2 into, so 12 over sine 55 times 28. Now those guys are going to drive me crazy. I swear to God. I really swear to God. Into cos of 2 times 55, that's 110. Okay. So I've done it. If you put everything right, it's going to be 1, 2, 7, 9, comma 1, 8, 1, 6, 7. Please don't round off. So we do the final gymnastic. So therefore AE is, I'll just say square root answer. It gives us 35, comma 7, 7. Remember, this is meters. Don't forget the units. All right, nice and easy. Okay, here it was a bit naughty. Not too naughty, but a bit on the naughty side. All right, so how do we score marks here, guys? Writing the rule is good. I don't know, guys, there's so many things now. We can just say substitutions here. The final answer. Yeah. I don't know, guys. 4 marks, I don't see where they come from. I really do not. Because which one would we mark? Which one would we abandon? Okay, just extra mark for the whole job, I guess. So sometimes the allocation is not so easy to predict. We are doing some easy 11 marks here. Easy 11 marks. Easy. Now, let's get to the Euclidean geometry. Okay, so question 8. Question 8 says, in the diagram, O is the center, yes, of the circle, and LOM is the diameter of the circle. Okay. LOM is the diameter, so this means this must be 90 degrees. Ne? Yep. And if O is the center, so it means that OM and OS are ready. Now, what else do we know? We know that a line from center to the midpoint of chord is perpendicular to chord. So that's the story being propagated. So we saw the notes that I gave you guys when we talked about the perpendicular bisectors of a triangle. It means they are concurrent at a particular point. Right. And where is that point? when we have a right-angled triangle. Anyway, masingishiye khona lapho. You must have done your homework. If you didn't, you are dead. So if this is isosceles, so this angle as a whole must be equal to that angle. Angles opposite equal sides in that small triangle. And we can clearly see that the angle at center surfaces here. Okay, maybe we're reading too much right now. Let's move on before we become crazy. Of course, these are corresponding angles. If they are like that, it means this line is parallel to that one. Right? And on top of that, we could have just concluded that this is the midpoint meeting the midpoint of the other side of a triangle. So the midpoint theorem already also holds true for that parallelity. And it even says more. ON is half of PM. Okay, so please see these things. ON bisects chord LP, yeah. At N, we saw it. T and S are points on the circle on the other side of LM, okay. We see that with respect to P, not a problem. Chords PM, MS, MT, and ST are drawn, yeah. PM is equal to MS, yes. And MTS is 31 degrees, not a big deal. So we're happy. So we understood the diagram anyway. So we also knew that if this is that, then this angle is double this angle, right? This is the angle at center, 2 times the angle at circumference for the same chord or arc, MS. Now, let's just leave it at that and not complicate it, because we will probably regret. We don't want our diagram to be too busy for us not to see what we need to see. Now it says determine with reasons the size of each of the following angles. So we've got A. We need MOS. MOS, it's very easy. It's going to be equal to 2 times angle T. This is angle at center equals 2 times angle at circumference. Right. This implies, please folks, be systematic. I know. You don't want to follow things right. This is what makes you so poor at simplifications. Because algebra beats you guys because of this nonsense of always trying to jump to the conclusions. You lose when you have to deal with stepwise approaches that are complicated. But if you get used to simplifying by just simplifying simple things, remember, you don't start by simplifying hard things. You simplify simple things first and make it a tradition. Then you will see how you will thrive even with the tough questions where simplification is a bit of a flip-flop. You will just appreciate the challenge. But hey, I know you are taught the wrong way. I will say it that way confidently so. And I know someone is going to cry for it. But hey, go and cry in a corner somewhere and come back and let's do maths. All right, L. How do we find L? L. Remember, L must be equal to this angle T. Why? Remember, these are angles subtended by equal chords at circumference. So we know that, well, angle L is equal to T equal to 30 degrees. Here I can do that, although I hate it. In fact, I do hate this way of writing. Why should I? So these are angles subtended by equal chords. Given PM is equal to MS. Multiple sclerosis. Do you know multiple sclerosis? So we make a conclusion, therefore angle L must be 31 degrees. Is over now. But it's over now. Statement and reason important, and the conclusion. Please, I know you want to just say L is 30 degrees, angles subtended by equal chords. Which chord? Which angle? You see? Don't talk nonsense here. Please, simple lift off. I am in a good mood and I don't want to lose my temper because of people who are just crazy. Now it says we need to prove that ON is equal to half MS. You see, this one is just to try and say, since this is equal to that is equal to, but we need to just talk about midpoint theorem. And how do we drive it to the midpoint theorem? We need to talk about the parallelity. Parallelity. Of course, we need to just speak about this being radii. That is already the midpoint. Once we join two midpoints of a triangle, like that, that will be parallel to that midpoint theorem. So we may not even need to state the angles per se, but it depends on how we want to say it. You understand? You understand? So I'm not going to go through the route of parallelity. I'm just going to go through midpoints. Just state that this is always the midpoint of OM somewhat. Then if it is joining that other one, and that's the case, I don't need this other one. Okay, all right, okay. I'm going to say here in triangle LMP. The last menstrual period. Oh, what are you talking about now? Talking about biology. Biology. Well, we understand that we understand that one, OL is equal to OM. These are the radii or radii, and also that Ln is equal to NP. This is given. We can say therefore, I'm trying to say something, but I don't know if it's going to make sense. Therefore, let's just say ON must be parallel to PM. This is the midpoint theorem of triangles. Midpoint theorem of triangles. Therefore, we understand that essentially ON is going to be half PM, which therefore concludes that ON is going to be half MS, given PM is equal to MS. Yeah, this one was a very weak question. Swag this one. But I do believe we needed to state this, although it was quite evident. But this statement is powerful. Perhaps it just introduces this situation right here as a whole. So we know that this conclusion is good, and the substitution, although it's given, it still gets a mark, I guess. I don't know. It's a very easy question after all. So let's get to 8.2. 8.2 is proportionality theorem that I taught you very well. So I hope you practiced, because these kind of things are going to haunt you in the exam if you did not. In triangle ABC, in the diagram, K is the point on AB such that this is the ratio. AK is 2. So AK is to KB. Is 3 is to 2. So we can choose a multiple and say this is 3A that is 2a. Please always, when given these ratios, when you write them in here, choose a particular multiple that keeps them in that proportion, or else you will make a mistake of thinking those are lengths, and that's not the case. Okay, that's the simplified version of what could have been something else. Take it as an empirical formula against a molecular formula. Molecular formula being the actual length, empirical formula being the simplified version of whatever those were. Anyway, so N and M are points on AC such that KN is parallel to MB. We can see that. BM intersects KC at L. We see that. And of course, another ratio is given again. So AM is to MC is 10 is to 23. So if this is 10Y, that's 23y. Again, we choose a multiple, not to suggest that those are lengths. Nobody said. If this is in ratio form, then we're not going to assume anything. All right, so what do we have here? 8.2.1. We need to find AN over AM. Wow. This is nice because it means we're working on this triangle. So this is very easy. So we can state in triangle AMB or ABM, we understand that AN over AM is supposed to be equal to AK over AB. This is the prop theorem. Remember, for this to be valid, we need to have the set of parallel lines. Without them, this theorem is not valid, so don't leave it behind. If you leave it behind, you die. So it implies that AN over AM is equal to AK, which is 3A over AM, which is going to be 3 plus 2, this is 5A. Now these ones grace us with the gymnastics, so we can say therefore AN over AM is going to be 3 over 5. Nice. Okay, so this is easy, straightforward stuff. So of course that and that is what matters here. So 8.2.2, we need to find CL over LK. Great. And then this means we need to find this part here. Okay, so easy guys, because we found that this business here over that business is what? 3 over 5. So if this is 3 over 5 now, for this to be 10, 2 goes how many times to 10? 5 times. So this must be 2. Y. Of course, guys, this is 2y. Of course, if you like, you can assign different ratios, if you will, and then work it out. But of course, if we're saying AM is 5, and we see 10y here, then it means that must be 2y. So that when we say AN over AM, we get, don't worry, sentence I put. I made a mistake. For this to be 3, it must be 6. Must be 6. Right? Yes. So that 2 goes 3 times. 10 goes 5 times. The key was to get to 5. 10 and 5 is 2. So 2 there must be like that. So that's the idea that we are getting. And if that is 6, this is already suggesting that this is going to be 4y. Can you see, guys? You need to know things. You need to know things. You need to know things because this must all add up to 10y. Nice and easy. So what are we going to say? CL, we will know that in triangle KNC or CKN, whatever. What are we going to say? We will see that in this triangle, we still have these parallel lines going on in there. Okay. So this is the triangle there, and we see that. So basically, the key to this problem was to crack this 4y. Now, this is where we need to be very, 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 very careful. You get it? We need to be very careful there. So now this means we need to represent AN in terms of y. You get it? We need to represent AN in terms of y. From there, we can work out NM in terms of y, and then we can go for the ratios eventually. So this is one of those questions. Although I just did it, you have to showcase how you worked it out. So now, I suppose we're rushed. We don't want to start there. We want to start somewhere else. What we want is to say, fine, we understand that AN over AM is 3 over 5. So we leave that as a ratio. This implies that AN over AM from that split, it's going to be over 10y, is equal to 3 over 5. Okay, just cross multiply the y there. This implies that AN is going to be equal to 3 over 5 times 10y. Now do you see this goes? That remains. Therefore, AN is going to be 6y. Can you see? It comes out. If this is the case, what are we going to say? We will say, therefore, NM is going to be, or perhaps let me just show you the right way of doing things. We can say also, we know that AN plus NM should be AM, right? It's evident, which implies that 6y plus NM, which is what we want, is going to be 10y, right? Therefore, NM is equal to 4y. Great. We can say then we can appreciate that in triangle. Okay, let's not even waste our time here. We can just say then we understand that CL over LK must be equal to CM over MN. Or should we say, whatever we say, guys, we can say this is the prop theorem with LM parallel to KN in triangle. We can name it now, say CKN. If we care to be alphabetically what, this implies that CL over LK is going to be CM. This is 23Y over MN. We got 4Y. So the Y's grace us with their absence. Therefore, we have a conclusion here. So sometimes I understand, guys, these questions are frustrating in that you end up feeling like for 3 marks so much to say, yes, this is a hidden higher grade question. They hide it by giving you less marks so that you think this is simple when it is actually not that simple. So this is how examiners can work on your nerves so that you can get punished a bit. Okay, all right, okay. If you liked, students, you could have used still that triangle that we shaded. I mean, there's many ways of killing a cat, because you may want to argue about this lanky business here. You can use this triangle, right? Just say the challenge is NM. You can say NM over AM, right? Is going to be equal to KB over AB. Then that falls nicely into a ratio. This one you don't know, but you know this is 10Y. So this can help us to work out this NM in terms of Y, so that we end up with the answer right here without all these long lengthy businesses. Just shows though that logic can also take you through it either way. And then once we have this, we then zoom into this triangle nicely. So that could be just 2 steps instead of 3. But at the end of the day, you more or less are going to do this much work. So cry about it, come back, we do the maths. We do the maths. Is it the maths or the math? It's actually the maths. It's not the math. It's the maths. Because we say mathematics. We don't say mathematic. You get it? It's mathematics. So we say the maths. Not the math. We don't say that. Anyway, anyhow, you are the one. So that is the one. This is the powerful statement. This is the answer. The rest was your own problem, as you can see, guys. Now let's get to some more serious stuff. So question 9. Okay, I've taught you guys how to do this thing, so I'm going to move quick now. So in the diagram, tangents, okay, let me not teach you bad habits. Tangents are drawn from point M. Where is M? This is the one. Outside the circle to touch the circle at B and at N. So it means this is a tangent. And that one too is a tangent. Tendabane dombe ngoku. Zangafeli impuku esandleni sami okanye intaka. Okanye inkukhu. No. Nothing died on my hands. I let nothing die in my hands. Some belief, some belief doch. I cannot shake like this. Okay, so these are tangents, but what matters here, folks, is the fact that tangents from the same point are equal. And if they are equal, it means this becomes an isosceles triangle. These become the opposite angles. Sorry, the angles opposite the equal sides. Nice and easy. So since this is the situation, it looks like I am rushing things now. Can you see this was already given and we just needed to add this one. Oh, this is so interesting now. Okay, we just wanted to still show that these angles are equal. And we also appreciate that that angle is equal to that angle. Because if those two sides are given equal, and that's the case. So x and x, so this makes this one 2x. Double those angles. Lord. Holy cannoli. Okay, so we can stop there now. Let's read more. What we say, the straight line from B passing through the center of the circle. Yeah, straight line passing through the center of the circle meets MN produced at A. Okay, nice. So this is to suggest this is still a straight line, Okay, but now what do we know? What do we understand? We know that the tangent meets the radius at a right angle. Okay, great. Now, we are told more that NM produced to K is produced to K such that BM is equal to MK. Umkhonto wesizwe, BK and BN are drawn. Let K be X. Great. Now determine with reasons the size of N1 in terms of X. Holy cannoli. We will do it, but with some difficulty. We have many ways of killing this cat. We can use this isosceles triangle here. Work out M1 in terms of these two being X. That's going to be 180 degrees minus 2X. Right. And we can say this is the exterior angle here, which is this one plus this one are the same. So we can say 2 times this, N1, gives us that. So this literally becomes 90 degrees divided by, 90 degrees minus X. Yeah? So that's exactly the answer here. So that can be looked at that can be looked at that way. Or we can look at it this way, that this is an isosceles triangle, but I think this one is going to make us a bit unhappy. Let's just go for it the way I've seen it. Sometimes you don't want to look at it too many ways. If you solve it, it's over. If you can't, then you come back and look at it. Or the other way could have been to say this and that is equal to that. So this is 2x. From here, this is an isosceles triangle. It still works out the same way. All right, okay, all right. So I'm going to say, well, in triangle, the main triangle here is BMN. But I'm going to use the other one as well as a means to an end. What do I know? I know that M1 plus B1 so clock. What I wanted to say was that N1 plus B2 is equal to M1, right? Exterior angle of a triangle. This is the one that I'm talking about. So this implies that so let's just leave these ones for now. So N1 plus B2 is going to be equal to, this M1 is going to be 180 degrees minus the sum of K plus B1. First of all, I just want to furnish a reason for this. I know that let's say k is equal to b1. No man, don't worry. This is the sum of three angles of triangle KMB or BMK. Let's just say BKM. Now this is to justify this 180 minus what I'm saying, because that I have not changed from that triangle. So this implies that N1 plus B2 is equal to, now we have 180 degrees minus, now I'm going to say here 2 times angle K. Or we can say just K is X plus X as well. We justify this and say K is equal to B1. These are angles opposite equal sides in triangle BKM, with MK BM, equals MK. Okay, so at times, yeah, your creativity can be put to the test. Fine, we know that N1 plus B2 is going to be equal to 180 degrees minus 2x. Okay, so this implies that 2 times N1 is equal to 180 degrees minus 2x. Again, we furnish a reason why we're doubling that now is because we know that basically N1 is equal to B2, right? As these are angles opposite equal sides in triangle BMN. Okay. Yes, and yes. But now this is very interesting. We need to still provide a reason with tangents. Yeah, okay. I think here it's gonna kill me. My creativity is gonna murder me, but you understand what I'm trying to say. These are angles opposite equal sides. We can still make this one a more complex thing. We know that basically with MBM equals MN, which is tangents. From same point. Holy cross, that was a massive reason, I suppose. Of course, guys, it depends on what you want to say. This is still okay. No one is going to say no, man. No, man is not allowed. We can say, therefore, N1, which is what we want, is going to be equal to, when you divide by 2, it's going to be 90 degrees minus x. Thank you. I'm trying to say less, but yeah, it's getting me in trouble. This one is good. Definitely. This reason is important somewhere, somehow. And then here, this one is also very important to say. 6 marks, ne? So this is a mark. That can be a mark 1, 2, 3, 4, 5. Where's the 6th mark? Yeah, guys, it can be anywhere. There's a lot of things here. Tangents from the same point. Yeah, whatever. But we can say 2 marks here. Statement and reason together get 2 marks there because the reasons are quite fairly detailed, if you will. So let's look at 9.2. 9.2 says, prove that BA is a tangent to the circle passing through KB and N. KB and N. Eu guy, Haribone, KB and N. Siye kanje. So inkinga zethu ziningi ke manje, so izofuna siyithi ke ngo ke ingathi izoniqhela kabi, masibeke kanje. Wanicala must sit on those 2 points. Izobambi. Damn it, man. Ayihlalanga kakuhle mos. Yabona ke nalicala efanele balibe lincinci. Ke masenze kanje. Asiyenze that one. Seyigqibile. Okay, ufuna ungiqhela kakubi kancinci. Ingiqhela kakubi nje kancane. Hayi, siyayiyeka ngo. Ihlangene. Hayi. Ya, ne. Sekhona ukuqhelwa kabubi izinto. Wona sohlangahlangene. Kuwa yonke into. My tablet is falling from my hand. Guys, I'm falling asleep while working. It's bad, eh? It's not good. Okay, so yeah, folks, we need to prove that this BA is a tangent. So what are we going to say? How do we prove this to be a tangent? It means we need to prove that this angle is equal to that angle. Right? Because that would satisfy the 10 chord theorem, being the chord, the tangent, and the things. Okay. So that means we need to solve this as what we say. All right. Okay. All right. So this is easy because we know that this is equal to that, which is 90 minus x, and this whole thing is 90. So if we say 90 minus x, it will leave us as x. Okay, so let's just say, first and foremost, MBA or ABM is equal to 90 degrees. Why? Because we know that this is tangent perpendicular to radius. Because the radius is, we were told this line passes through the center, so the radius is like that, okay? This implies that now this becomes B2 plus B3 equal to 90 degrees. Which also implies now B2, we know that we set B2 and n1 are the same. So this is 90 degrees minus x plus b3 equal to 90 degrees. So these dudes will cancel. So we will then say, therefore, b3 is equal to x. We will therefore say, we understand now that angle K, or perhaps let's just say, therefore, angle B3 is equal to angle K equal to x. This is, let's just say that H is equal to x. Maybe let's not rush for conclusions. Right, what are we trying to get to? We want to get to the conclusion, therefore, AB is a tangent to circle passing through KBN. The reason this is the converse of tan chord theorem. You guys, I'm fried. I am very, very, very tired. Okay, so this is good. So first of all, statement and the reason. Here, substituting B2, I suppose, and proving that this is x. And of course, the conclusion is quite clear. 1, 2, 3, 4. So the extra mark is linking these two, maybe. We can let it be like SWA. Not a problem, guys. A very easy 11 marks here. This is standard grade things. Whew. Yani. Alright, guys. Yo, ditiniwe. This one is for you guys. Never. 10.1. Niyaqoka. Nalena ndayenza at some point, God, but masiyiphinde. Oh, I hate to repeat myself, but yeah, this one and this we answer. Let's do question 10. And then 10.1, I'll just say C, books. Because this one is on the books, I don't need to show you. You need to see and you need to practice so that you know what is the steps or what are the steps necessary to take here. Nice. So 10.2, I've done this question in the past. I don't remember that, but I think I deleted the video because it just was a junk video. You know, when videos don't really increase in views at all for over months, it means they are just in the junk status. Nobody sees them, and the algorithm hides them from the people. See, sometimes this YouTube is a waste of our time. We do so much work and then it just hides the video when it chooses. And then the useless ones, it shows them to everyone. Then those ones increase in whatever views. And I'm like, oh, it's deliberately trying to starve you guys of the right information, but give you garbage. Anyway, whatever. In the diagram, O is the center of the circle. And CG is a tangent to the circle at G. Great. So that's the tangent. As highlighted. Of course, it's going to go all the way like there. All right. So that's what we see. Okay. The straight line from C passing through O. straight line from C passing through O, cuts the circle at A and B. Okay, so this is a straight line. I would like to highlight it as well because this can quickly be misunderstood. Nice and easy. Now the diameter DOE, see, is perpendicular to CA. Great, that is the perpendicularity. And if it is the diameter, it means this angle. Nope. Is 90 degrees. Nope. It's 90 degrees. Is it 90 degrees or 90 degrees? 90 degrees. But we know that this being a straight line, AB will also subtend a 90 degree there. Ayison papela wena. This thing. Skatlon papela wena. Skatlon tina watsiba batlon tina jwale. Wa tla nketsa dihlako tsa hao jwale. O sontina loba ke ka jwang. Loba ke ha jwang hantle. Hantle wandela musne. So that's also angle in the semicircle, angle in the semicircle. So there's an overlap of 90 degrees there. Nice and easy. So is there anything else? Yeah. Chords DG, BG, and AG are drawn. So they are already here. So we're good. We are good. If we are not better. Haiba hari better. Now 10.2.1. It says now prove that this is a cyclic quadrilateral. 3 marks DGFO. So this is clearly a cyclic quad. Why? This is 90 degrees given. We will discover this as the angle in the semicircle. So the opposite angles are supplementary. Therefore, that should be a cyclic quad. So we'll say angle DGF or FGD. Let's just say DGF equals 90 degrees. This is the angle in the semicircle. Right. This implies that DGF plus DOF, what was it? DOE, no? What was it given as? DO? There's no DOE, no man. Different okay, I'm sitting with DOF. DOF is going to be equal to 90 degrees plus 90 degrees. It was given that DOF is perpendicular to AC, right? Given that DOE is perpendicular to CA or AC. So this implies now that DGF plus DOF is equal to 180 degrees. Therefore, DGFO is a cyclic quad. This is the converse of opposite angles of a cyclic quad. If we find the opposite angles to be supplementary, conversely, the quadrilateral in question has a circle around it. Okay, this was just 3 marks, not a big deal. The marks are here. Then to show the supplementary nature, the final with the reason. Great stuff there. Great stuff there. So that was A, B. We need to prove that GC is equal to CF. GC, CF. Okay. All right, okay. Okay, this one is naughty. This one is naughty, but not too naughty. All I know is that from the cyclic quad, this angle is equal to this angle. Right? That's the exterior angle of a cyclic quad. But then how do we link this back in here? Because for this FC to be equal to GC, these two angles must be equal in there. These ones must be equal. Alright, so this is equal to that and equal to that. But the question is that how do we get these to be equal? We know G1 is equal to A. 10 chord theorem. And then how does this A help me? Oh, this question, why are you troubling me now? Why are you troubling me? When Scotland gets its Tomona. I am not interested, man. I'm not interested, man. But I know this has to come in somehow. Yeah, this question is going to irritate me now. I'm so tired. And I'm feeling like I'm losing the time. Elimination technique here seemingly is going to come to work. But this angle is equal to that. Whereas this angle from this gives me that. But if that is 90, these are complementary. So this is going to be 90 degrees minus that. And and then of course this one is also 90 degrees minus that. So these ones are equal. I don't see it, man. I don't see it. I don't see it. I don't see it. How do I drag this? Why did I struggle, man? This is easy, man. It's tiredness at play now. It's tiredness at play. Can you see this is the angle between the tangent and the chord, this one, and the chord subtends that angle. So ziyalingan. And this one is equal to that. It's not actually difficult. See, tiredness can work on you guys. Answer Euclidean first. Believe me, you will be happy in your life. Otherwise, Euclidean is going to punish you. So let's start. We will say we will relate this to this triangle. In triangle CFG, what do we know? We know that this angle F1 is equal to angle D. Why? This is the exterior angle of cyclic quad DGFO. Right. We will say also we know that this angle G, okay, let's just call it CFGC, is equal to also angle D. This is the tan chord theorem. So this implies that now angle F1 is equal to this angle FGC, right? Because each equals angle D. Therefore, we can make the conclusion that GC is indeed equal to CF. These are angles. These are angles opposite equal sides in a triangle. We're talking about that triangle CFG. CKB. So this is good. This is good. Linking the two and the answer. No. These are the sides opposite equal angles. Or somebody can say converse of angles opposite equal sides, because that's literally what it is. I see 4 marks. I don't know where is the 5th mark, but then it means there's a statement with a reason that is marked correct. So perhaps we can say here statement and reason. Sounds interesting, or anyone. This 2nd mark can be drawn here, can be brought down here, but since this was already suggested, perhaps the reason is more important. So either the first statement or the 2nd statement and reason will qualify for 2 marks, while the other one takes just 1 mark. I guess since this was already proven it's a cyclic quad, perhaps 1 mark there, maybe 2 marks here, because is hidden, this one. So it depends on how this was meant to be done. So 10.2.2. Now this says it is further given that CO is 11 units. Now we're going to do some calculations. And DE is some 14 units. Now, what is the story? We need to calculate the length of BC. Okay, CO. And then DE. And we need to find BC now. Okay, BC is the one in question. All right, okay, all right. What is the story that we must tell? So remember, CO is this whole length right here. It's this whole length, which is 11 units. And then we want BC. Maybe let's show it much nicer. Okay, it's part and parcel here. And it's just 3 marks, so this means it's easy. But it could be higher grade hidden with these easy marks right here. DE is this side. So what does this mean? This already says if this is DE. Okay, let's use another color. If we have DE as 14, this means it will cut. Remember, this is the diameter, so it cuts in half. So this should be 7. And this is a radius as well. It means it's 7. All right, so this is clear now that BC is going to be literally 11 minus 7. We need to talk about that. we talk about that. Right? We gotta talk about that. That's how we're gonna make it work. So we will say, first and foremost, this is what happens. We know that OB, I'm just gonna say OB is going to be half DE. Why is this? It's the radius. Is equal to half the diameter. I don't know. You can say radius. I think this is the radius, seeing that this is the diameter. I don't know. You can say D is the diameter. You can say OB is the radius. I suppose this is fine, as complex as it is. So this implies that OB, which is what I want, is going to be half of 14. Therefore, OB is 7 units. Don't want to beat around the bush. At the end of the day, we know that it says what we want. We can say then, we understand that OB plus BC gives us OC or CO, which implies that 7 plus BC is going to be 11. Therefore, BC is going to be, is it 4 units? Yes. Ne. Yes, 11 minus 7 is 4. Alright guys, you take cartel, man. This is good. This is good. This is good. Okay, so we go to B. B says we want the length of CG. Now this is going to be a bit naughty. So you say at the question, we want the length of the tangent. Dang. But did you know about the theorem? There's a story that I need to tell you guys. So you see guys, the story says, now these are the notes. If we have, for example, let's say we've got a circle and we have a tangent. Okay, let's just draw it here. Say this is the tangent, and of course the tangent behaves like the tangent. You know, there's a, let's say now there's stuff like SWA. Right? So we can call this A, B, C, D. So if BC is the tangent, we are told that BC squared becomes the product of the segments of that other line there. Should we call it a secant? I don't know what we call that line. So this is AD times DC. So that is the theorem. It's a theorem. What do we call this theorem, Kanen? Yo, in memory, I'm guys, if you know, what do we call this thing? Yo, Wafetso. Is it secant tangent theorem? I think something like that. But I think we used to call it tan sec theorem. I think it's something like that. Tangent secant or secant tangent theorem. So it just says the square on the tangent is equal to the the product of the segments of the secant, right? Something like that. So we see something like it here. We've got a tangent GC and we've got the secant CA because it cuts the circle at 2 points, B and A, and it is produced. So this becomes a secant. So we can use this thing. So I'm like thinking 5 marks, maybe not, we'll see. Remember these are ready. Okay, so we can use these things. So I don't know, these 5 marks looks like they're being thrown at us. But whether they're being thrown or not thrown, we will see what to do about them. Yeah, I tell you guys, my chair just makes noise. A lot of noise. So what are we gonna say, guys? What are we gonna say? Guys, I don't know if you're allowed to do this. I know though that GC squared is going to be equal to AB times BC, right? I'm gonna write tangent. Come on. Tangent secant theorem. And we actually did prove this one. There's a way of proving it, but we prove it through similarity, isn't it? Because we'll say this small triangle right here. You will see that this small triangle and this big one right here are the ones that get used in the process. Right? So we will use that business. So that small little triangle and that, because this is equal to that 10 chord theorem. This is common. So this means that one is going to be equal to that one. So those are similar. Then we use the proportionality of those sides. And guess what? This is common to two triangles. So it's going to square up. And it's going to end up giving us the vibes that it gives us. You get it? Yeah. But I think my not AB, man. Isn't it AC? I think it should be AC times BC instead of AB times BC. Yeah. So it's going to be AC rather. Right. So this must be AC instead. Yes, because when we use similarity there, so you can prove it using similarity, guys, but I'm not interested. But I do believe this comes from the similarity. The 5 marks wants to come from there, because for 5 marks, you're not getting these ones. Because this would be for 2 marks, right? So we would say this implies that GC squared is equal to AC. Now remember, AC is literally the 11 altogether plus another 7 here. So this is going to be 11 plus 7 times BC, which is what we got, 4. Therefore, we know that GC is going to be the square root of what we have here. Which is equal to, so there's no way we're getting 5 marks for this, but let me see if we can't. So this is going to be the square root of 11 times, plus 7 times 4. Okay, maybe let's just put a bracket here to avoid trouble. Okay, I'm getting 6 root 2 units. So nobody said how we should give the answers here. If it is not stated, I can leave it at this. If I want, I can leave it at whatever you call. So I would suppose, guys, the statement and the reason get 2 marks. Calculating AC is a mark. And we can simply say general substitutions is another mark here. And the answer. So we can actually make up 5 marks here. Although it looks crazy, but sometimes just look at the approach. If the approach does work, just get to it. But the way I say it, it looks like someone must look for similarity, which I've already highlighted. You know that you're going to look for the similarity. Look at similarity of triangles BCG and ACG. I think that's a clue, and I've already shown how you're going to work that out. From there, you take it to the proportional sides. Strategically, making sure that the common side GC gets squared. Okay, so that's how this would work, and then substitute. But I suppose this is good enough like this. It's not too complex, but of course it's a tricky question. Now let's see, this is C. You know. Essentially, technically, zonke bonke we need E. Okay, how do we get U? Okay, so, well, we've got this side, right? But now we don't know OF, because I'm looking at this triangle here. This triangle must try something for us. This one has to try something for us. Ibonakala ngathi ilapha lento. Imona ntweni. Why? Because these are angles on a straight line. They sum up to 180. If the other one is 90 already, the second one must be 90. But the challenge for us here is to find OF. Because if we can find OF, we've got OE somewhat as 7. So we can use the tangent of this angle. It can give us this. See, trigonometry is coming back. So again, this makes this one a higher grade question as well, because wow, in fact, these two, they are both higher grade questions. Ne? Because they are not direct. How ban? So these are higher grade questions because, yeah, there was a bit of thought, although I summarized it nicely here. How do we find OF? Well, this is going to punish us a bit. It's going to punish us a bit. This OB, ish. Now I'm having a situation because I need FB to come up as well. And yet it's just 4 marks. Guys, are you kidding me? Or am I just too sleepy now? I don't know. FB, how will I find FB? Thola kanjani hlele kone ekhuzwayo emashamplan. Emashamplan andiyiboni kahle ke guys ngoku ithanda ukunixaka. Oh, ndilibele yawena sengiqhela. We found out this one was, and we proved that this is an isosceles triangle, this GCF. So if we got GC, we've got FC, and from FC we take out BC, we get FB, and FB will then lead us to OF. Nice and easy. Dang. See this part, this is the part that links up nicely to this one. Yeah, I always told you the examiners will play with your head afterwards. So, well, we understand that FC is equal to GC. This is proved above. Right? Right. Now, from here, we will then suggest that this implies that FC is equal to GC. What did we find? 6 root 2. Which also implies FC now is made up of FB plus BC. 6 root 2. This implies that FB plus 4 units is going to be 6 root 2. I hope this is right. Why do I feel like it's wrong? Therefore, FB is going to be 6 root 2 minus 4 units. Okay, sometimes we do get stuff like this that is totally irrational. Now, sizofuna uthini besifuna ukuthi ke ngoku then we will say then in triangle OFE ufe emongwana dintho tse sharp o ska bapala ka yena. Okay, off. What are we going to say with off? We need to establish certain things. We know that this EOF, right, plus that other angle which was DOF. I don't know if I said it that way. I should get 180 degrees. These are angles on a straight line. Please, guys, don't shy away from these little calculations, but you just need to know how to do it. We're interested in EOF, not GOF. So this means EOF plus, this one is 90 degrees. It was indicated equals 180 degrees. Therefore, EOF is 90 degrees. Okay, we need to establish that. It's important. Also, that OF plus FB is equal to OE. Did we use OE anyway? Because I'm feeling like I don't want to do other things. We set DE instead. Okay. OE. OE. Okay, let's start by saying OB. Okay, this is evident, which implies that OF plus this one is going to be 6 root 2 plus minus 4 is equal to OB is nothing but OE, okay, which is 7 units, right? So we can just easily say OE, OB is the radius. Yeah, ayikasendiniwe. And ungaboqala ngezinye questions ugqibele nge-Euclidean iza kubulala ufe. I got a Lenny question ingathi outrageous, guys. OF is gonna be what? 7 plus 4 minus the square root of minus 6 root 2. This is gonna be 11 minus 6 root 2. I tell you 11 minus 6 root 2. Okay, this is 2.5, so that's not bad. Okay, it's good. Units. This one in Atian Pekas and side conjugation. What did we say in that triangle? We wanted to establish the 90 degrees. We wanted to establish this. We can say, maybe let's not say then. We can say, however, city then. We want to say now sine, not sine, but 10. Yeah, 10. E is going to be 10 of angle E is going to be equal to, the opposite is OF over adjacent, which is OE. This implies that 10 angle E is OF is 11 minus 6 root 2, all divided by OE is going to be half of DE, which is going to be just 7. This one we're not going to explain anymore. Therefore, say E is going to be the shift 10 of 11 minus 6 root 2 divided by 7. Okay, this one is a naughty question. Again, you see, it hides the fact that there's a lot to do, but perhaps my approach is too long, I suppose. Shift 10, 11 minus 6 root 2 divided by 7. I'm getting 19,7 degrees to 2 decimal places. Okay, that's small. It's very acute. It's very acute, so I would take it. Yeah, the last one, maybe I've said a lot, but again, guys, I'm just showing you what links to what and how it goes and how it works. So it's just 4 marks, but yeah, there's so much we said. Anyway, let's go for it. So what are we trying to say? I think this boils down to this business. Literally. This boils down to this business. The rest is not so interesting. And OF and the answer. Yikes, this is bad, but hey, it is what it is. So that's it, guys. I do hope and believe you have learned something and that this can be a very good practice for a student, So this would be 26 marks for a grand total of 150 marks if I did not commit any mistakes elsewhere, which is possible, because I am not even going to wait to review these answers I have given you guys. I'm just going to give them to you in a video. So if there's any mistakes, I'll try to use the comment section to try and rectify that, or you guys see for yourselves what to do. And as you can see, paper 2, guys, is long if you are going to explain. And you can see I tried to talk less this time, but I still went to 4 hours instead of the usual 3 hours that you're supposed to do this in. Of course, when you know what to do. Oops. I'm tired. And you want to strategize. I told you, start with Euclidean geometry. Okay, even in Euclidean geometry, don't start with the easy ones, okay? Okay, maybe start with the easy ones, yeah. So that you build up. But what you want to do is to eliminate these tough questions. For example, question 10, you may start with it instead. Do the proof is easy, then you come here. While still fresh and able to think, you take your time and do this. Then, after that, you may want to say, if you're feeling fresh, I want some easy questions. You come to these ones. You save time for this one. It may challenge you here, but you take your time here, finish it. Then you say, okay, I've taken some hard hits, so what is next? I don't want to lose easy marks. You come here, take question 1. While you're still feeling good and fresh and refreshed, you can decide, okay, usually question 4 is naughty. Come here, take your time, but these are marks you can handle with ease. Maybe take another easy one, 5. Then you can skip this and come to this one. It usually challenges students, but it's not too bad. You chow this one, then you come back, you chow the function, which is not so bad, then you chow the rest. Again, these are not too difficult. If you feel though they are overwhelming, you go back and perhaps chow the second question here. You can spare time by quickly finishing that. Then you come here, perhaps as your last question, and you want to know that, again, I can do this in a hurry. This is a question you can answer in a hurry, as opposed to the others. Okay, even when you're tired, I'm telling you, you can finish this paper on time and still have some time left to double check and triple check things. But yeah, paper 2 is not so friendly though. Make sure what you do, you have looked at it and proofread it the first time, by ensuring that the answer makes sense, as well as you accept how it looks on what you have, and then you move on. All right, so that's it, guys. I hope to see you next time. Goodbye.